Reciprocating windmill flower. Anyways, it's an engine design I was talking about because it's like we can 3D print an engine design, to not have the need for bolts, to have a lot more gained out of it, you know, in terms of compression and seal. There's maintenance issues, but if you can 3D print engines like crazy, then it doesn't really matter. They're cheap enough that you could probably just stick a new one in. But I said it's garbage. I hate the latch design that slides in, latches on, especially since the vibrational resonant frequencies almost always cause a leak somewhere. And then I had to get around it by putting a fucking stupid little straw piece into it to basically make itself slide in a weird way with an oval design that would slide into the right place. And it just didn't sit well, and it never worked. Really, all I mean, it worked. That solved the issue. It just was annoying. If I'm being honest, it was really shitty to have to deal with. So I ended up heading towards my ultimate hydrogen design. Which is a regular hydrogen design. Okay, but it's like hydrogen comes with this major efficiency issue. And sure, you can gain this heat with an increased exothermic reaction with my oscillator engine. But it's like, I need people to understand that that's a nice engine, but it's not a great engine. It's very inefficient. If you intake where the center of a circle is and use that centrifugal centripetal compression by inputting hydrogen in and using the same exothermic style reaction of air and contain on the outer sides of a piston, like reciprocating piston, that is a one piece design, because you can 3D print a hollow tube with multiple sections that has the right valves that can be attached to intakes and scoops and all the rest of it. So it's like instead of a regular piston head design, it's different for sure. It's more akin, I would say, to a kind of like a potato chip. It's a good way to put that. It's not really a potato chip. It's like it's fairly close in a way, and it has still a wrist pin. It's just a different type of wrist pin. You know. Anyways, it's a flat curve, but it's a curve. Okay. Take your hand, put put a little bit of a cup, curve your fingers outwards. You know, and now you've got it. But it's like, hey, you can't do it quite so much where there's a gap where your thumbs and your outside of your palms are. That's not going to allow for compression. But there's nothing saying I can't put something there and have it slide in. And then the interior tube, that is, of course, a tube, so it's hollow. You have in the center part of it your hydrogen. You also happen to have your ionized, deionized gases through your filter on either sides that inject into a massively compressed area that are very, very close together as they basically compress and use that motion to force an injection, like a diesel injection. It creates a compression ignition, detonation specifically. There's more than enough heat for it, or enough compression. But this needs to then go as your hands rotate downwards and they touch each other just ever so slightly. What does that look like to you with your fingers at the tips joined together, pressing it? Great scoop that's going to push it down. It's going to push it down pretty well. And there's a separator right there. It's going to be just fine. It means it's sealed more than enough. And then as it comes out, there's a similar design kind of style of valve, which is a butterfly valve that kind of opens up and allows some of the air to pass through. But because it's shaped just like that scoop, it's going to come off to the sides and go up around the toroidal donut ball, whatever the fuck shape you want to call it. But it's a curve that's going to press on the bottoms of your palms now and try and push it up. There's a little bit that you want to remain. That's your mixture of compressed air and water, steam. Okay? That creates a very hot, increased, very, very good style of propulsion. Because it's pushing down, it's pushing up, and it's helping rotate it further into the compression state, which is going to start the whole process over again on both sides, like a twin scroll supercharger. But it's a little better than you think, because hey, I have this also compressing and sucking in air, separating my air, compressing, injecting, turning faster, and if I cool a little bit of it just before it goes into the tube, and I compress it just a little bit before it goes into the compression central area, which really I just need to run some water, cold water over it, you know, I gain an increase of density. Pressure isn't quite as high, but it's much denser, and I actually need that to gain an advantage of increased power delivery as it expands more significantly. But like, kinda don't, if I'm being honest. Wink. Truthfully, it's a heat engine. If you don't know, you don't need it to lose any heat. In fact, you don't want it to actually lose heat at all. The hotter it gets, and supposing the materials can handle it, the better and more efficient it is going to be. Because you want that air to heat up and gain more pressure as it's injected. You want that hydrogen to do the same. That means less energy is lost to the design of maintaining temperature. So it's actually more efficient for a detonation, compression, ignition engine to be like that. It's a very efficient design, but it's not quite done. It's not quite perfect. It's not really the best of the best possible, kind of, if I'm being honest, because you can always add more rings. You can always add more air. You can always add more hydrogen. But my design really just focuses on maximum efficiency for heat being gained for my Stirling engine that I've talked about, and for my turbine that I've also talked about. With the new turbine Stirling engine kind of T-joint style, where the housing of the turbine is almost effectively right on top of this, Stirling engine, that loses its heat to the cool side and uses that to its advantage slowly over time to dump the heat back in when necessary to maintain that efficiency of that part of the exhaust area for the steam, thus soaking the entire thing in heat and running it around, making it more efficient and more powerful as a generator, which can still be used to turn into mechanical motion should you choose to. But my basic ass bitch detonation style hydrogen engine will run you pretty damn efficient right off the bat, be pretty small, only require some basic ass intake area. I mean that. They literally just stick those cones on the front and allow that exhaust to go anywhere that isn't going to burn you. And it's going to produce a shit ton of RPM. A lot. In fact, the better design runs at the more efficiently higher RPMs. You want those higher RPMs. Those are very good things to have. And in fact, that's a shit ton of torque and horsepower or wattage overall if you so want to do that. Combining two of those into one single output is not that hard for a transmission. For two of these little engines, two of these little circle rings, one engine, for one of these engines, for two of those things, I've got more power than most 300 goddamn horsepower engines because I can easily hit incredibly high fucking RPM. It's not hard to do that. I can easily get into those 100,000 figures of RPM. I don't have valves that I need like what they think I need. I don't. In fact, I technically don't even need valves. I just need it to open and close at only one spot in the entirety of its rotation, which I guess is a valve. But technically, you know, in a way, I don't have moving parts in that aspect if I don't want to, because it will only open once that's achieved. Then what we're talking about is a valve, yeah. But I'm not trying to get tricky. You have to remember that we're talking about a centripetal compressor that has a central intake area with your hydrogen being intaked in the center as well, separated to the other ones and allowed for the regular air, not the other ones, to allow for an increase of pressure gained. Much larger compression the faster it goes. And so what that means is only at that area is an opening exposed that allows for it to go through. Everything else is just compressing for the amount of time it's moving around. Spinning, that is. No moving parts except for the spin and the wrist pins. That's about it. Making it far more simple, far less likely to break, far easier to maintain, and is easily 3D printed. Incredibly easily. And it's a detonation engine, something they don't have right now. Not really. A piston-driven detonation engine that works beautifully as a detonation engine. That's right. In fact, faster it spins, the more detonation it gets, and the more efficient it becomes. Talking massive horsepowers, massive torques, all needing the right material design. That's all. That's all that'll ever be necessary for that. Material design, the right bearings, the right fucking fluids, all that kind of stuff. Because you want it to be hot, but you don't want it to melt anything. But we're talking about steam. Steam, which, if it decomposes, if it gets hot enough, turns into hydrogen and oxygen. And now that fucking goddamn injection of compressed hydrogen and oxygen is cold to restabilize, gain even increased amounts of horsepower and torque as a result of recombining the exothermic reaction and creating another detonation. As a result, going faster, getting more horsepower, getting more torque, getting more. It's truthfully just abysmal, if I'm being honest, how shit it would be to turn into a fucking goddamn transmission with a flywheel or something. Because it's its own flywheel, if I'm being honest. It's like, don't worry. I know I sold you. Like, we'll figure out how to attach it to something that makes it go burr. And I'm like, that's cool. That's nice. Here's the caveat. There isn't really something. What? And like, I'm going to be really honest with you. It's actually really difficult to get something that's spinning at 100,000 RPM to be stepped down to something that can move your tiny little car tires. Which now they're massive little stupid suckers, heavy bastards. They're like, yeah, well, you need that now. That's the biggest issue with that one. Because it's like, oh yeah, no, what about those gears and the freaking goddamn fluidic clutches and all the rest of it? And I'm like, there's a reason why I'm like that transmission is the main issue. Anything that's a transfer of power that at that point does not want to slow down. By the way, it doesn't want to slow down. It wants to do the exact opposite. It wants to speed up faster, 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 faster. And so you need to fuel limit it. If you don't know, it's a fuel limited design, not a heat limited, not a fucking valve limited. It's a fuel limited design. And material design constraints as well. Great design would destroy anyone that designs their vehicle to use this basic hydrogen. It gains massive efficiency. But here's the kicker. You stick the right counter-rotating turbine or counter-rotating turbine, depending on how you decide to look at that. But anyways, with your Stirling, you don't need a catalytic converter no more. You can recycle the heat. You can use the correct RPM to gain an advantage of using an ultrasonic or otherwise vibrational heat pump for the liquid and fluid moving around. There's only so much heat you can gain. From anyone that's worked in steam, you know that there's a decomposition point of the steam that you create. But you really shouldn't mind about that. You need to mind about back pressure issues. If you're going to stick that onto the back of a turbine, you now have what is effectively a massive amount of back pressure because it's a detonation that is sending its shock wave up, around, back into, and then back out, trying to diffuse what is effectively a massive pressure wave through a counter-rotating turbine. Which isn't really totally, it's technically the one axle is the one rotation, but then like you have blades in between that allow for a counter rotation. which is good because that absorbs heat, but it's bad because it's a big, heavy diffuser. There's a lot of back pressure, which is great for a detonation engine because that means you have a lot less bang shouting at someone. And by shouting, I mean it's a fucking bomb going off effectively that you're capturing energy from. So it's loud. It's so incredibly loud. By the way, I connected my Bluetooth hearing aids, for the microphone. So like it's going to be a little louder, and I'm talking a little quieter if you don't know, but it's closer, it's all that other stuff. But anyways, what I'll tell you is it's a loud, loud engine that sucks with how loud it is, and I mean that. And it works wonderfully. And I mean that for a hydrogen design because there's extra air being introduced and left in. It's not a perfect combustion. You don't need it to be. In fact, you don't want it to be. You want that steam to absorb and give you pressure and get repressurized to give you increased compression, ignition, detonation. But that is a thing that you need to understand when it comes down to the hydrogen style. It's actually possible to make this a hydrocarbon design. And if you do it with the correct ducted, because now you have a ducted, active ductive airflow, diesel injected engine. Stick the diesel injector in, allow for the Venturi-Bernoulli's principle, whichever one. Yeah, and then squirts in with the jets, fires off forward, slightly countered really, to each other, and then outwards like a bloom of a flower. And you're going to want to curve it slightly. Okay, so that way they'll head towards each other and they'll spin. And then that is also entering in one area while the other one is entering in the space left in between, filling the entire volume with an incredible amount of burn, which is more of a detonation. Shit, yeah. And if you don't know, great. Good stuff. Honestly, brilliant, bravo detonation engine. Totally capturable in terms of its energy, even with that nice side to side thing needing to be, everything needing to be geometrically designed to handle the compression in the ceiling much better as it rotates naturally. That way, you're not going to have those issues quite as much. They're still going to need, because this, instead of like hydrogen, by the way, that's going to get hotter. It's a much larger bang, too. There's a lot more air and fuel going in, and you only need the one on each side to inject air together, along with intaking all that extra air, too. It's like you get a little bit. You only do it in the beginning, a little bit. You only do one detonation every so often. You know what I mean? Because you're trying to fill it, prime it with a bunch of air. You need to. You need that extra air. And then you need to learn that it's like as it's going out, instead you have to have extra. Instead of just one area like hydrogen can have. Because it doesn't matter, it's just hydrogen detonation, that's fine. Steam is good to go. But what's the problem with a hydrocarbon? It's starved for air. So you need to pump more air in, which means you have one that's on the very outside, one that's on the very inside where the actual detonation is occurring. You still have a little bit of exhaust remaining. That gets added in with the air. That compresses it even further. It compresses it again and adds more air in, and it adds more fuel. Most of it's going to be burnt. If we're going to be really honest, I don't see much not being burnt. But by that point, for sure, after the initial startup, they should have a way to gain momentum, mass, extra air, extra heat, extra burn, and all the anything that is captured in that exhaust is going to be immediately reburned. By immediately, it's really just the stuff that isn't quite as burnt. Because if you remember that top of your fingers, it gets spread outwards to the side and then it goes back up as it ditches that area. And then it bounces back off the hands on the other side on the way back up to the top. Yeah. And it's like that is a I forget what it is, but it's a turbulent It's actually just a vortex flow, if we're being honest. It's a vortexing flow that now has a way to get sucked backwards, and then it uses the vortexing to open itself back into being and draining that spin energy into being a thrust energy as it bounces back off the hands. And what that does is it filters heavy particulate matter towards the exhaust, like the majority of it, which there shouldn't be really any soot considering an active ductive airflow design like that that's that extreme. You know, like I love the idea of hydraulic pressure and it will work. It's fine. But this, I don't need it no more. I've got it already. You know what I mean? In fact, I don't even need valves, technically speaking. I just need the openings, like I said before, but I don't, I mean, because of the spin, the pressure that's involved. But I'd prefer to add just a small little, as it rotates in those areas, little little pistons that move inwards and press in with the right, amount of O-ring seals as best we can. This gives me just a smidge more pressure that it would be nice to have, considering. Although, you got the active opening holes, right? And it's like, yeah, that's kind of one of my main issues are with my diesel injection engine. See, that would be wonderful with the ducted airflow design. It's going to spray, it's going to do all this thing. Beautiful design. The issue for me is the fact that it's going to go backwards. Barely at all, if I'm being honest. At all. I'm being really, really obtusely bitchy about it. It's almost no actual air going through those tiny holes. But there should be some, and that's an efficiency problem that I have with the design. And so it's a sliding valve design now that as it rotates to that after it's compressed and ignited, the valve comes down and then it goes back up and it rotates and it goes back down and it goes back up and it follows the angle with the piston heads and the tubes. So it slots in between, and now there's an active valve. It's not really an active valve. In fact, if anything, it's just there. And I'm not even kidding. It's like right there is the only opening in that ring valve I have that allows for the injection of the air and everything else. And then everything else is just a sliding fucking goddamn, oh yeah, no, it's no air. It's going to just get compressed, except for that other area, which it's like not really going to allow for air to come through the diesel active air injection. Instead, it just allows air to go through for the piston head area. No diesel injection is going to occur. And technically, the better way to put that is it's just going to add in air into that area for the piston head area. It's not going through the piston head. It's going through the in between of the piston heads. So it'll just add air in, which is fine because it goes through the tube and then it gets recompressed Now I've got higher degrees of compression, heat, speed of RPM, less maintenance still than any regular engine, shit tons of torque, large amounts of clean burning fuel. It's going to be slightly more powerful than a hydrogen. Not much. If I'm going to be really fucking honest, it's not much. Like, hydrogen's fairly close to gas. It's fairly close exothermically to gas. The difference is its burn rate. Gas happens to have a very high burn rate. Hydrogen has a very fast burn rate. And that's the main difference between the two. Gas burns with a higher degree of heat, which can be changed and maintained, because truthfully, I have to maintain to have an extra amount of air in my design to be able to keep the increase of detonation continuing. Okay. But for a hydrogen design, I don't need extra air. In fact, I want to keep that heat much, much higher. I only need the right amount of air in hydrogen. In fact, that gets better and better. There's more and more steam. There's more and more driving force, more and more pressure, more and more decomposition to the hydrogen and oxygen, gaining me back another recombination of the decompositioned air and fuel. It's fine. In fact, the only thing I'd use the extra air thing for is to go, okay, yeah, no, we hit melty temperatures. We hit melty temperatures. We hit the problematic temperatures. The material we used wasn't the right material. It's gonna melt. We hit the melty temperatures. Otherwise it's like, oh, that's fine. Go for it. It doesn't matter. Hit those high temperatures. You want the high temperatures. That gives you your efficiency. Tremendous efficiency. You need that. So that's the main reason why you want that style of design. It's not a perfect design. It's still pretty damn good. You know what I mean? Like, in terms of maintenance, cost, effectiveness, reduced parts, I mean, it's tremendously good. It's brute force, build a fuck ton fast, put them out there. You don't even need to do that much. You just need to make sure it's got the right amount of seal, the right amount of correct material that can handle the heat and the rotational speed, the stretch, the tensile strength that's going to be there pulling on it, with the heat that's involved, like any turbine, you know what I mean? Which is why I call my turbine piston engine. It's a turbine piston, because technically it's a piston, and it's a turbine. And it acts just like a jet engine, because the faster it goes, the more air it sucks in, the greater degree of compression, and the greater degree of detonation, and the greater degree of power you're going to get out of it. So I've gotten around a little bit, not much though, but a little bit, of the amount of efficiency issues that you're going to see for running an engine at higher speeds. It's like, okay, you start at a lower speed, you get going, it gets more efficient. Far more efficient, turns out, because I'm sucking in more air, and it's far easier to gain a ram air intake, and in fact, even use a two-piece design that sucks in for the beginning front part to a larger back part that is just the same freaking engine, and make it more efficient by doing that by a large amount, actually. You see, I'm now using the same engine just in the front, but they're both sides of the intake, like any jet engine will do for you. Now I can bypass that and run it regularly, and then as I get further along in terms of speed, I activate those to gain my already increased air consumption and intake speed, increase the compression while increasing the compression of the air around me, gaining me an increase of air, heat, decomposition, detonation again, effectively creating a ram air that's very efficient ram air for a small scale that isn't really a ram air, folks. It's like a ram air, but it's not a ram air. You see, it is, but it isn't. I'm using exhaust as a ram air now. My relatively slow speeds here of a car, a couple 100 miles an hour, maybe 100 miles an hour, maybe just go with 70. We're on the we're on the highway. We're at 70 miles. We got a big honking intake. Just shucking it in, small little tiny diameter. Input, small little thing. That's all that is. It's double fluted design. You got your another large, cone shape basically for your intake. For the tiny ones, of course, you want to deal with that. Okay. And you get way higher compression, way higher degrees of decomposition, and much greater degrees of detonation, much higher degrees of RPM. In fact, terrifyingly large RPM. It's dangerous. I have to let people know. If we design it with the right material, it's totally feasible, not too dangerous. It's scary, I gotta admit, because you'd hear a jet engine. I mean, you'd hear like a never-ending bomb when you run up your engine. It's just a little. And I'm not trying to scare you. It's just I want people to understand that this is a different type of engine. It's a new type of engine. It's a rotating detonation turbine engine that has a scramjet basically attached to it. It's a ram air intake scramjet basically. Because it's throwing in exhaust that's getting added to the ram fast enough that we're basically scramjetting at that point. We can effectively create a powerful decomposited hydrogen and oxygen into the hydrogen or regular air intake, combined with more air intake, firing hot steam into the detonation hydrogen air area, thus increasing even more of that very thing. There is a limit. Remember, you're not gonna get all decomposited, all because of the heat, turned into oxygen, hydrogen, elemental gases that are too hot to chemically be stable. You can get pretty close, but you can't get that far. You know what I mean? But it's more of a, sure, we can do that, or we can just have the regular engine and not do that. I like that type of engine, and it's actually not that hard Because a smaller engine, two of the smaller ones can feed one hell of a large one if you do it right. That's more of a you thing. To me, I would say that's useful for a style of rocket slash jet engine hybrid that we might want to try some cool inertial confinement fusion, perhaps, or particle acceleration inertial confinement fusion with extremely high pressure steam, elemental hydrogen gas, and oxygen. That's going to fuse a little bit. It's a small amount. We only need a little bit of plasma to really do that, you know, which gives me helium. It's going to give me increased pressure, heat, speed, and velocity. Because as much as I love to talk about this, it's like I can only intake so much damn air, bro. You know, there's only so much air I can take in. Props are props, man. Like, there's only so many blades you can put on the darn thing to get more airflow. There's only so much size. When you're talking about hundreds of thousands of RPM, eh, mm, eh, I don't think that would be as worth it as some people might expect. You know what I mean? But it's still worth it because I'm producing a large amount of electricity. I can turn back that rotation energy into something that is more reasonable without having to use a step down gear and turning parasitic mass loss of the mass needing to be turned into a resistive electromagnetic generating electronic, you know, good old electrons, forces, right? And get to it, just like electrons. I want to get as electrons. If I generate electrons, I can use that for my particle acceleration in inertial confinement while still maintaining the correct amount of prop speed, exhaust speed, intake velocities, ram air intake velocities. It's all just a series of stages now of air speed, the right altitude, and the right ignition sources at the right areas, acceleration forces for the given gases. And now I have a little bit of fusion that will gain me more efficiency by a large amount. And I can always carry oxygen and suck the shit out of that oxygen in that I can't actually fuse or can't actually combine back because I'm losing the amount. Because remember, while I started with that energy, I'm losing oxygen to be combined, recombined with the hydrogen. I have to burn more hydrogen to get that back. Or I can keep that oxygen in. If I can try and gain a little bit of that air, suck it in, compress it in a tank, I can use that. It's mostly nitrogen though, which is a big issue, but truthfully, we have a way, especially because of how freaking high up we are and how much colder that is, with the right filter, that we now have a dramatic amount of air pressure to push through it, gain a nitrogen, liquid nitrogen that is, out of the filter, which should gain a increase of oxygen. Or we can just use oxygen if I'm being honest, because that's easier. This is an oxygen filter. I get tricky with it if I want to drop liquid nitrogen into the coolant area of the, jet engines and everything. There's nothing saying I can't do that. There's nothing saying I can't use that for a temporary amount of super conducting or near, high temperature superconducting magnets that are only going to last for that amount, in a small amount of time here. that's necessary for them to do their job. While we're getting into the very upper atmospheres, and then continuing past into the non-atmosphere, gaining a rocket engine. That's a fusional design, which is really just using deuterium and tritium as your fuel source with your compressed oxygen on board and already available oxygen, because, there's nothing saying you can't do that. Dump it in together. It doesn't spin a prop no more. It's not necessary. So instead, you just turn it into electricity. You turn it into a pump. You turn it into incredibly high speed velocity gases. You ionize the hell out of it because you're producing a large amount of thrust already from that. And then you have deuterium and tritium, much easier to fuse at a very steady rate. I can use less oxygen, far leaner mixtures, just enough to maintain the electricity and airspeed velocities, as in exhaust gases velocities. Turn it into a plasma, compress it again, shoot it with lasers, shoot it with electromagnetic forces, and hit it again with some particle acceleration. Nothing wrong with that. I already have a rotational thing. This thing's spinning quite fast, dude. Sure, I can use it as a pump, but I don't need that much for a pump. I don't need that much for electricity. What are we doing here? And I was like, particle acceleration. It spins. It gives me particle acceleration. Want more power? That's what it is for me. You shoot it down the tube as it spins, rotates, and then we jolt it with electricity as it goes through, or electromagnetics, really, for being honest, because we have liquid nitrogen. We do. You don't know. And by the way, that nitrogen, that's my way of making that stupid damn sucker not burn. I'm spraying that in there. So you think I'm not spraying that thing in there? I'm spraying that into the fusion area because that absorbs heat. That compresses immensely the amount of that exhaust gases, compression, and then recombines with any hydrogen that was infused, absorbs that heat, expands the nitrogen. There's oxygen, wants to explosively decompress because it's nitrogen and oxygen. And whatever hydrogen happens to exist. And I go even faster as a rocket engine, far more efficient, far faster. Mach 12 or above speeds, truthfully. That's the real issue. It's like I'm actually not efficient. It's starting at relativistic speeds, where that particle acceleration fusional area is, and the injecting liquid nitrogen area to absorb and not have it die. I'm slowing down every step of the way, and it's actually annoying me. You should know I don't like that. And yeah, sure, I have more mass, but truthfully, because of relativistic speeds being what they are, I gained far more mass going at those relativistic speeds in terms of actual thrust and specific impulse than if I were to do the liquid nitrogen. But you have to, because otherwise you end up having melty issues. It tends to burn and melt. So I've been looking further and further into a design that's like, okay, so how the hell do I turn into a rotational into an ultrasonic cavitation design that uses explosive decompression, the heat, the suction, the cavitation, along the side of a separation of the two to gain an increase of a spring style whipping action in the turbulent flow area to no longer become turbulent, instead to become a vortexing whip compressor area. If you don't know what that means, it comes in, it spins, it explosively decompresses, creates a cavitation, it compresses, it bounces off others, decompressing and getting stuck as it explodes, it then compresses, it then also creates a cavitational area. That cavitational area sucks it in, forcing it to basically whip, like go really, really fast turn, a gravitational slingshot, yeah. It then flings it out even faster in a very specified straight line. I haven't gotten there yet, if I'm honest, especially since it's kind of annoying to keep consistent. So I've been thinking about something else that's far simpler. Just keep it super simple, or keep it stupidly simple if you can. The easier, the better. So I ended up thinking about something else. Something that's a little weird, something that's a little out there, something that uses the fact that the damn nitrogen doesn't combine very often with everything and it just kind of expands. It doesn't really give me everything I'm looking for out of it. It's still liquid for a long ass time, even though it's in almost no freaking atmosphere, almost 5, 6, 7 inches downrange from where it gets injected. Should be massively decompressing. And so I've started looking further into like what those issues might be that are causing that. And I haven't gotten there yet, if I'm being honest. Really, yeah, because I want sonic designs. If you don't know, I like ultrasonic frequency designs to separate and mist the design, but it's not really creating what I'm looking for. Uh, so I've been just sort of focusing heavily on that damn afterburner area because we have a huge afterburner area. We have a massive afterburner area. Like it is hot, very hot. Even though I cooled it down, it's very hot, but it's not accelerated. It's a lot of mass, and that's what really gives us our massive kick and thrust. And sure, to someone out there that isn't me, Mach 12 is quite efficient and fast. Especially since I'm pushing what is stupid amounts of mass out of the damn thing. Which, accelerational wise, you'll already be at that point where that makes sense, so don't worry. You're not gonna die, you're not gonna suddenly hit like 8 G's doing. But I can totally understand the fear. Absolutely get it. If I thought about that myself without knowing about some of this stuff, or even knowing some of it, but not really kind of taking that into account, it would be like, what the fuck? I'm gonna have my neck snap. That kind of thing. And that's not what I'm looking to do. So I've been focusing more and more heavily on that afterburner, and I don't really have a way to really turn it into what I want right now, considering it's so incredibly hot, incredibly pressurized, and incredibly fast moving. Like to put it in perspective, we're near the temperature of standard nuclear or fusional reactors. we're at a pressure that is uh, a few 100,000 miles into the surface of the sun. You know, like digging into the sun, like what we theorize for it to be at. We're at that level. It is not melting. Well, no, because most of it doesn't touch the sides. Most of it's still just heating up a bunch of nitrogen that's more or less surface tensional liquid shitty things boiling that are just it's not working the way you want. It's not. It's annoying me. Everyone, if you don't know, this is stuff that annoys me. It should be gases already. There should be no liquid at that temperature at that it just shouldn't be, but it's definitely still liquid. It's definitely cold enough. The temperature of the surface area of the afterburner shell is colder and cold enough, and it maintains that cold long enough for you to keep that as a liquid for a very, very long time until it boils at the tip, you know, which is frustrating because it's like that's a lot of lost energy and efficiency. I don't even have to inject much into that to create fusion, right? The answer isn't yes. The answer isn't no. Anybody that doesn't understand me on that one, I absolutely get it. These are these are weird things I'm dealing with. So like nitrogen doesn't have a very large amount of fusional energy to give. That and the main real problem, if I'm being honest, is that it's accelerating away from you instead of towards each other, which lessens the impact of any particle accelerator design could ever feasibly be able to achieve. There's no real spin or plasma style electromagnetics at play. Eh, there isn't. It's like just one direction, and that's a field in its own right out of the shell, which is a big frustrating design problem I have because it's like, oh yeah, no, I basically have a plasma particle accelerator. You know what I mean? Which is nice and lots of mass, cool stuff. Inefficient. It's a lot of heat, a lot of lost velocity, a lot of lots of stuff actually. Yeah. And he's like, how did you get it to be a plasma? And it's like, it's not really. It's like it absorbs it, but it's like so hot it's plasma. You'd call that a plasma at that point. You know what I mean? So, but it's not technically a plasma in the sense that you would probably call that like reasonable for a plasma, which is a problem. Like the core is a plasma, but the outer side is not a plasma. You know, and by the time you get to the skin, no plasma, just liquid nitrogen. Golly, effective in in all ways. It's very effective as an insulator. This is what you want. It's what the whole reason why I designed it is like it's not gonna melt anything. This is proof of concept stuff, and then I'm like, right, cool, nice, proof of concept over. I want this to do better. I want this to do way better than what I'm doing right now. It's annoying me. You have no idea. It's like, why can't I make that go bang bang better? You have, haven't you? Well, I thought about it. Scoops inside the afterburner. Well, you need to redirect the flow and create like a weird vortexing that sends it back in and creates a circular effect, wasting energy, only creating a marginal amount of area for some kind of fusion. If you might be able to get it to not die and melt. Exactly, that's the problem. That's why I didn't use it. But it's like, I don't want to think about it. I want to think about it. It's like every time I'm like, how do I make it fucking? It should be good enough for anyone. It's like, why do you need to think about it? And I'm like, they know why. It's a spaceship engine, dude. It's a way to use your regular ass single cockpit little fighter jet to suddenly go halfway around the world or fully around the world in orbit for a while for the cheapest amount that you can think of. And it's also terrifying for any military or government. Think about that. We're talking anyone can get anywhere in the world in a few minutes to hours, depending on how much G load you want to take on. Or if you don't give a fuck, you can handle the G load and it's just meant to impact or blow up. And that's their problem with it. And I'm like, cool, but I'm still focused on this afterburner area. Nice, cool things. All right, let me think here. I want to inject things. I can't inject things. I want to inject things the opposite direction. Damn thing just doesn't want to fucking get very far before it hits something and doesn't really work. And it's like, oh, I wonder if I could put stuff in between and like create like little channels. And I'm like, that's one of the best designs that I've come up with. And well, I created a problem with the explosives. It's starting to happen by a runaway chain effect. So if you don't know, neutron release, fusion, increased compression in a given area as expansional profiles happen, in an increased amount of heat, a sudden increase of electromagnetic intensity. It's still velocity moving, as in moving with its velocity, but actually some things slowed down, other things speeded up massively. That slowed down and that speeded up. Which is kind of a uh-oh. So it's an explosive chain reaction. Almost. If I'm being honest, almost. I can't really control it the way I want to, which is a constant thrust. But if I do it in a series of really finely, and I mean hyper fine control, holy fuck, this is not worth it. Came back. I was able to get some thrust, like a pulse jet engine. It wasn't worth it. I didn't think about it though. Really? Yeah, because it's like, I'm getting somewhere. I can self-sustain a reaction, can I? If I can get it to like consistently pressurize, and it's like, no, 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 not that. No, 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 not that. But no, because that pressure has to be maintained, and there's nothing controlling and maintaining the pressure. And anything has an equal and opposite reaction, regardless of magnetics. Magnetics will still push against each other. So that's when I started heading towards other avenues. Really, yeah, because it's like, this is totally fusionable with really, really small hydrogen atoms. In only one area specifically, I had to design it with a toroidal shape as it exhausts, which it should already technically be, but it's not. It's a cone, more of a column or like a single cylinder, because it fills it up, and then eventually it just kind of comes out, that way. But it's like if I do the right kind of aerospike design, where I'm firing an incredibly fast plasma of hydrogen injected correctly, by the way. And I mean correctly. It's safe enough, though. It's an afterburner for a reason. Afterburners, generally speaking, aren't usually what you would consider to be without problems. But I have a different nozzle design, a different shape design. I have a whole bunch of stuff, but it is very much a kind of point and click. Yeah, just go that way. You're whatever that's the direction. You're not doing anything with that much. Like you have slight amounts of control. You don't want to use much. And that's a good thing, but it's also dangerous. And yes, I am getting fusion, but not much. It's more of a fusion there, expands, ricochets down, fusion again, expands, no more real fusion, no more real fusion, heating, heating, heating. And then at the very tip, because there's this pressure that's bouncing around as it goes down back and forth, it creates this resonant frequency that creates another fusional event with some helium and hydrogen that didn't quite fuse, and nitrogen as well. Right. And that is very stable. It's pretty fucking good. What's the biggest issue with it? It's hot and explodingly fast. Nearly the speed of light, for sure. We're near the mini nines in past 99, in terms of the speed of light. So pretty good, pretty dang good. It's still nitrogen mixed with a little helium and hydrogen, so not extremely high mass. But because of that relativistic speed that I now have, and the fact that the matter is it's accelerating the hell out of the rest of the exhaust that's around it as it's trying to expand into it. And there's a bunch of exhaust there that's going to just gather all these electrons and anything. Just go away, go away. Shoo, shoo. As it just fires it out fast. Still in the relativistic speeds. 80, 60, 70, some of it's even 90 too. Same amount of mass, almost. A little more now because of the hydrogen. Technically, because of the relativistic speeds of these things and the extra mass gain that happens to come along with fusion, and the neutrons that are being absorbed heavily into a very dense gas plasma area. It's not all of them. It's a pretty decent amount. It's a lot of mass that's going a direction that is not where you are. It's the opposite direction, behind your ass. And it's captured well enough with a bell housing at that point. I have to have a bell housing for that point. If I have this afterburner, I have to have a bell housing. There needs to be a bell housing, otherwise you're not really capturing it. Like the gas expands, it needs to, impart that into something. And so it's like I have a bell housing specifically designed for this sucker. And now we're really going. Really, really going. And before it was mass, at Mach 12. Mass at the Mach 12. Really quite fast. Good. For your speeds, a slight slowdown maybe, depending on your mass. A little nice pickup boost. You're going to pick up some speed. You hit your afterburner, you're going to pick up speed. You're going to the moon about an hour or two. I can easily maintain 1G with pretty high velocity, pretty high masses, pretty quickly. But you don't want to do that because you don't have tanks for that. You don't have tanks. Anybody that's like, I could go to the moon, I'm like, you can't get back. probably. I mean, maybe if you hit the right, like, inclination in orbit, you'd probably land. You'd probably get back. Hopefully, it's the right, like, re-entrance for that. But otherwise, I wouldn't do it. Even if it's an hour, it's like, yeah, but it's not like you have 1G acceleration, bro. You're still just floating around in your little cockpit in your little tiny fucking space plane. You know what I mean? Nice pressurized cabin and all that. It's good. You can do it. It's fine. You gotta aim right. There's space computers for that. Don't worry. You got that. It's good. Just I want people to understand. I'm not suggesting you do that. It's really just meant for getting around the planet quickly. To be fair. But go for it. Honestly speaking, I'm not going to stop anyone that tries. It's their shit that I built. It's my shit that I built, their shit to do with what they want. That kind of thing. That's how that works for me. I'm fine with whatever they decide. I'm just not going to tell them that they don't have risk. There's definitely risk. So, other than that, I think it's done in terms of like what you can feasibly get out of that engine. You know, um, is that about it? I have a plasma injector style design that's a smaller version, not using super conducting magnetics, super electromagnetic or conducting magnets. I don't have any of that. It's still achieving decent results, actually. Um, Nothing impossible. It's a little bit of fusion. Um, Not much. I mean, it's the right ceramics, it's the right seals, it's the right, particle accelerator as it's spinning, I'm spinning it clockwise, counter corkscrew, whatever, as it's heading towards the injector area and getting that increased velocity, which then like a laser ring light, which isn't hard to make, if I'm being honest. Um, it's just a circular lens, not a lens in terms of like a flat circle. It's just a ring circle of lens. That is a inertial confinement style, but with a very, very, I talked about this design because StyroPyro came up with, the world's largest, brightest handheld laser or something. And I'm like, there's a way to do better than that. There is. And it's like, so as a laser, we're going to diffuse the laser, is what I said. It's like, why would you diffuse a laser? It's like, why would you ever? I mean, it's already. Why would you just concentrate it? And I'm like, there's a method to my madness. So hold on. And so we diffuse it, but not diffuse in the way that you might expect. So we want to diffuse it in a very particular, famous quantum experiment, a slot experiment, if you will. But that would be kind of rough to do. And so my initial thoughts were such that that wouldn't be very good. And then I went and kind of just backtracked on that really quickly. This is my past in the Chandler house. I was like, nah, I wasn't thinking about that. As I was thinking about that, that was definitely what I was going to plan on doing, but it would melt most things. And so I needed to diffuse it with a proper system, a proper, decent amplificatory crystal system. See, we have amplifying crystals. Green laser light isn't that bad. But it's not just amplifying crystals, okay? There's a incandescent style green luminescent design in between each of those crystals that have been specifically designed to diffuse them in the quantum slot experiment design, with a mirror on the inside of the tube that happens to be filled with a bunch of slots and grooves. Now, what are slots and grooves? To anyone, layman's terms, nothing but refractors of light that polarize and create superpositional polarizations, which you have a bunch of polarization, bunch of superpositional states already from this amplificatory crystal design that's diffusing in that quantum slit experiment. And in between each one of those happens to be an incandescent style that hits the green laser, and it's hitting the right frequency of green, but it's also turning itself off and on in the right resonant frequency to pulse it. As it goes forward, it's also diffusing towards the outside. It's just meant to go forward, outward, anywhere downrange. It doesn't have correcting lenses. It doesn't have anything. It's just a bright light. So what are we doing here? But we now just created a multiple entangled superpositional polarized light field, because as it goes off these grooves and slots, if you make them the right way, because now lasers are creating exact positional styles for those grooves and slots, with this adding to it, by the way, this just bright green light that is pulsing correctly through everything, resonating, amplifying, but because it's pulsing, it creates a very weird, entangly, superpositionally effect. Very weird. That likes to act very strangely downrange. Give me a second. Stick with me. Now, as it refracts, and as they combine, but they're not combined. What is this? Why aren't they combining? It still seems polarized. It still seems superpositionally. It's definitely not coherent, but it sure is going that direction, for sure. And it seems to be multiple different polarizations all at once, all around. There's many different polarizations existing in the same amount of places. In fact, many polarizational light waves existing exactly in the same place, exactly the same time, moving at exactly the same amplitude, wave, frequency. All of which are also in a weird entangled manner, all heading towards a corrective concentrating lens in the front, which is not just any lens. Mind you, folks, this one's a cool one. It's a flat lens, and a flat lens with a bit of water that moves in between that must maintain at least a 72. You can go below 72 degrees Fahrenheit, but at least 72, please. You need to cool the water. But any standard lens, and it's correcting it to a focal point. That's all that is. The water is the touch, the pièce de résistance, the big kahuna, if you will. The big boy that you want. You need to have this. If you don't have the water, it doesn't work. It won't work. It doesn't do anything special or spectacular. In fact, it's basically nothing. You've done nothing. It's a slightly brighter light. And it's like, yeah, but the water's the magic sauce. The water is you guessed it, refracting, amplificatory, coherenting, collapsing wave state to the light. It jiggles just enough, collapses the waves, vibrates off towards the right direction, amplifies the waves and everything else for your green laser light. It can be used wonderfully enough because water is amazing. Any light at all, it doesn't matter what light. Any electromagnetic spectrum, not even visible, not just the visible, I mean, all of them will work with this. Ionizing gets a little rough, if I'm being honest, because it likes to ionize it, but it still does work. But that's the kicker to this design. It, for the same wattage that motherfucker Styropyro was using, I'm getting 1.2 megawatts of continual energy on a fucking concentrated, and this is at the diameter of the magnifying concentrator lens, or not magnifying, the concentrating lens, focal lens, sorry, that then concentrates to whatever point, because it's 1.2 megawatts that is then getting focused into whatever point size you get, which is a lot more heat and energy than you think. Now, the reason why this happens to work is basically I coined the Lemke principle. That's my last name, and I'm the one that came up with it, and I'm the one that discovers basically it in terms of the concept. If you ever happen to do it, and these are all concepts that have been done before, by the way, but it's an amplifying effect of a quantum field. It's a Bernoulli's principle, a bunch of quantum wave fluctuations and polarizational light combined superpositionally and entangly. And then we get an increased amount of watts and power. And because they're collapsing in a very clear, concise, safe manner that's very directional, it's extremely powerful. It's not coherent, and it is coherent. This is the debate among scientists that will rage on forever, as far as I'm concerned. But it's mostly coherented. But there's enough non-coherented, bright, regular light that is just being focaled as well, that it's also just a focal lens on a LED light or something that concentrates it. But then it is coherented. There's enough there to call it a laser. But there's also hybrids amounts that are not. And that's because it's not a perfect design that perfectly mimics a laser. You need a separate lens and coherenter after to make it fully a laser. But what I'm using this for is pretty obvious and simple. A heating design for my plasma engine. I don't need much to make that work. In fact, I only need one or two of them that kind of roughly match the laser that is compressing alongside of the compression of the plasma, alongside of the electromagnetics that are compressing the plasma for that inertial confinement and particle accelerational. And then, of course, there's the physical nature of the compression, which increases dramatically heat, pressure, and the spark ignition that is one small amount of fusion from or a good amount of fusion, or really the right amount is what I'm trying to get for the particle accelerator and inertial confinement additive area that's to that, and pushing everything also together with it to gain a greater degree of fusion alongside of the heat that I am shoving into it. A massive degree of heat. megawatts, which is not needed actually at all. I don't need that level. I don't. I only need the small amount. Everybody's like, you need way more heat, and I'm like, I don't want that much heat. That sounds dangerous. It sounds really, really dangerous. Sounds too dangerous here, for me. Especially since that heat is going to get recaptured and then reused, and then as it spins, I basically gain a massive advantage. I don't actually need to use electromagnets that are as superconducting or as powerful as a double toroidal form at all, actually. In fact, that's not what I'm looking for. That would be dangerous. That's a bad idea to do that. It's kind of a beginning of my concept, if I'm honest. I was like, yeah, you could just do that. That's simple. Why not just do that? And it's like, just do that instead. It wasn't even that long ago I was saying that. And it's like, I've been refining in the background. I'm like, that's not a good idea to do that. Turns out that creates a massive amount of a fucking problematic effect that a lot of people are not talking about, that I didn't really see at first until I ran it long enough. I was like, oh my god, the heat's immense. Holy shit. Like, and it's firing faster and faster one direction. Yay. That's stupidly bad. It's really not good. I melted every fucking design I ever had. Because there's no way to change the velocity of the plasma fast enough. And it gets massively denser, and it actually runaway effects very quickly because it gains a pressure that wraps around the two toroidals towards the center. As that pressure gains and gains and gains and gains and gains and gains and gains, it creates a runaway chain effect that does actually just create a massive fusion bomb. And if you point, and I know that a lot of people are gonna be like, what would happen if you pointed two of those straight at each other? A bigger bomb. You have a much larger bomb. It's not even a joke anymore. It's terrifying, actually, how easily that creates a very, very, very powerful, multiple trillion ton fucking bomb, or even past gigaton, really, because that's small suitcase styles. To be fair, I also have to have like a small, oxygen tank together with it, but I don't want to get into that. That's like for the deuterium tritium, size, is that way it gets going and it goes really big boom. But and it's like, that sounds like a really good design. Why wouldn't you use like basically this mechanical design for your fusion? Doesn't last that long. It's good though. It's great for like a basic bitch car engine, maybe, or maybe like some airplane engines or something. Maybe some rocket, small rocket, flit around some places. You have to repair a lot of it. It's really a lot of heat, honestly. Like, it's a decent amount of pressure too. Like a tremendous amount of pressure. Like, I can easily design a hydrogen, even diesel injection. That's no big deal. That's actually fine. that's easy. The fusion plasma design, it likes to just be a dick about things. Really? Oh yeah, no, you don't know. I'm watching it. It likes to break, crack a lot. And if it doesn't do that, because it's almost always oh shit, fuck, uh oh, suddenly got way too much fusion than I was supposed to have. There's way too much. It's like randomly, it's just like, what the fucking shit? Why did we get like 1,100 fucking shit? Why did we suddenly get way too much fusion? It's not controlled. It's not controlled. Like, I can't get it to not just overrun sometimes. And it's not apparently down to like temperatures, rotations, it's just like some reason or another, like things just line up really, really, really well for the way the plasma allows the fucking laser and everything else. And we're now going through like we're gonna shine a laser for before, and we're gonna detect to see how much of a diffraction and blah blah blah. But for some fucking reason, still getting those random cracks of increased degrees of fusion that we don't want. So it's not a very safe design. That toroidal design is safe. It's not very safe. I can't even use it for a really. I could use it for like a rocket engine. I could technically. Why don't you say that it's not very efficient? It burns through so much energy. It goes like it's so inefficient. It is a bit, and it looks like a ginormous penis. I'm not gonna let anybody live this one down. If you ever decide to do it, it looks like a ginormous penis. It is a two-ball structure with a long tube. Strapped to another end that's just a long tube. And it's not very efficient. I keep trying to design it more and more efficiently. Really? Yeah. And you can't. Not that design, no. There's a reason why I'm sticking with that other design still. It's still the best design I have that I came up with. It's still the one I put out for a damn good reason. It's the safest, it lasts the longest, and it will work tremendously well. It is the fastest amount of mass moving, the greatest amount of that mass, the most efficient, and it still has refinements I can make to it to make that even better. This design is a torture test in superconducting magnetic material that cannot last for long periods of time at all. That one can. It lasts a lot longer. It lasts tremendously long. And the main reason why is the density of the plasma, the movement of the plasma, and the gaining that heat energy back safely, correctly, so that way it's not going to die. All of which I am, in order to do for that design, lose efficiency and do not gain increased mass or really increased velocity. I'm not really gaining much increased velocity at all. It's not even matching my other design. All stuff takes time though. There's a reason why I'm like, that's a great design, I'm going to change it. Honestly speaking, there's a point where I'm going to change that design. It's a great design, works wonderfully, but it's, yeah, I wouldn't even call it complicated. It's just big. It's a behemoth of an engine that will last a very long, long time. That's a better first step than that other toroidal, meaning two donuts in a tube, otherwise known as a fucking penis ejaculating design. All the time, because I also happen to have a tip, and it's necessary, by the way, that's cone shaped. It's necessary to literally get that last bit of fucking acceleration. I hate this design. I love the joke. Don't get me wrong. I'm all for penis jokes, man. You have no idea. All for it. It's fine. That's not the issue. We all love a good penis joke from time to time. It's not a bad thing. The problem is the damn design just doesn't do anything efficiently. I'm not even gaining the necessary impulse, specific impulse. I'm not gaining the necessary mass ejaculated out. You know what I mean? That's just what this is. If I'm gonna be really honest, it's like I can't make it the way I need it. And even adding more balls and different tubes, and at that point, I've almost basically designed the same thing as the other design. So I've gone through this for a while, thinking about what the hell I can do to make it more efficient because it's far simpler. Kind of. It's far simpler. Kind of. Like when you look at the entire picture of the main behemoth sail engine, behemoth class sail engine that Fusion design I have, it's like, oh no, that works very well. Works very well. It's fairly damn complicated outside looking in. When you get into it, when you look at the parts and pieces, the moving, but it's nothing that's really all that moving. But there is moving stuff. I should let people know that the stuff does move. It's not much. It doesn't move far, and it's actually really well designed and to basically make that happen as a release to the design. You know, it's a safety feature, really. It's just a really good idea to have. This one doesn't really have that. It creates explosions for a reason. It doesn't have a release. If it suddenly creates an increase of fusion, it doesn't release. It only creates a massive bomb. Because there's only so much that release valve and the tip of that other end can really allow to go through. You can only make it so big. You can only make it so damn big. If you don't know, you need that tube to be a certain size. It cannot be too long. It cannot be too thick. It creates a fusional bomb in and of itself that ricochets shock waves as it fuses, and it creates a compression ignition problem like in a regular piston engine where heat and pressure waves combine and create a fusional explosive within inside the tube. And so resonant frequencies are a big issue. Not to mention its heat loses out to the surrounding area that it's putting that into. And as you try and accelerate it, you're not actually gaining an increase of velocity as much as you may want. And then there's the smaller tube at the other end it has to go through. And you can widen that to the point where it's the same size as the tube that most of the plasma is there to try and vent out everything. But shock waves are three-dimensional, not one-directional. They go in 360 degrees. They'll go right back into those ball areas or toroidal and create a secondary explosive fusional pressure. It'll travel up the tube and blow up the balls. So you cannot have it too long. You cannot have it too short. You don't have something that can control and accelerate it. Because when it comes out, it's not accelerated that fast. You have to build it up so much more in the toroidal section. And really, you're just increasing heat. You're not really increasing speed as much as you may want. The speed comes from the tube. The tube is the speed tube, basically. So, it's just not the best design. Love the joke, or I love the idea of it, if I'm being honest. Especially since it's a nice putter as an engine. Especially if you happen to use a better design that happens to not take superconducting materials as a way to do your electromagnetic control, and instead use accelerators, which is something I started looking into pretty quickly because it's like this could be something. We need accelerators, like accelerators make sense. Yeah, we just need to have them create a very large amount of fusional compression ignition, all the right little chamber, like a little, rocket combustion chamber, and it goes down the tube, still the same, and it works out. Basically, ejaculation and the seminal fluid coming out together, one big glob that's constant. If I'm being honest, I mean it. It's practically exactly how that works. So, um, but there are caveats to that design too. Basically, another version of I need ricocheting pressure waves and vortex shit. I have to time everything to be incredibly precise. Not even getting into it, I have to bleed it out, because they have to keep a certain amount of pressure and heat within the area. And they have to allow for a pressure release valve that constantly comes out. And it's all the time, you know what I mean? So it's a great putt putt engine, if I'm being honest. It's efficient enough to get around from Earth to maybe Pluto, within a couple of days, because you can accelerate and maintain 1G and be efficient enough and stop for Jupiter or Saturn to get your extra hydrogen, scoop it up, push through the atmosphere, that kind of thing. And it works. You're going to be riding on the back side of a never endingly ejaculating penis. So just be warned. Just letting you know that it will literally be what it looks like, because a oblong particle accelerator, two of them, by the way, that is combining in a blast chamber before it goes down a correctly linked tube into a cone to accelerate the plasma and have it come out the other end correctly with the correct amount of speed, and uses electromagnetic and radio forces to effectively control it, to no longer be worried about the plasma coming back towards you, thus gaining you your very speedy ejaculate. Basically, it's not a lot of mass, I must admit. It's not. The most I can gain is maybe lithium. Like, you just don't get a lot from that design. It's just not gonna make a lot of fusion, and there's not a lot of pressure, not a lot of heat, and it's not a lot of acceleration that's gaining its constant, never-ending acceleration and heat and pressure like the mainsail behemoth class engine. So the specific impulses are very high, but the efficiency is massively better than like a standard conventional uh, hydrocarbon design, or even hydrogen and oxygen combos. It should get you to point A to point B fairly quickly. Not terribly efficient. It's not as efficient as that behemoth mainsail, but for a putter, getting to and from places, it's not bad. It's pretty good. It's like, hey, do you need what is effectively the best world's fucking most expensive, or whatever you want to call it? Like we're talking like hyper or sports car, something like that, versus you go to get groceries and like your sedan, and it's pretty cheap, efficient, for what it does, it's not the most efficient. I mean, there are obvious hypercars that have more efficient engines that produce a lot more power. They burn a lot more fuel, but that's what that is. But it's like, it'll do. I don't really think it's all that good, personally. I more just want to see people use it just for the penis shape. I'm not even kidding. It's just like, oh, that sounds funny as hell. A lot of people are just using their plasma ejaculating penis engines to get around their solar system. It sounds hilarious and funny to me. Can you imagine? It'd be fucking awesome. It'd be funny. I don't think it'd wear thin for very long. I don't think it'd ever wear thin. Be the new Romans. Like, penises everywhere. Got all the penises. Penises, get your penises here. Got penises on penises. What? Yeah, this is the penis 2, this is the penis 3. Which one do you want? They're not, they're the PNIS. Really? Yeah. There's no E. Remember, PNIS. What does that stand for? The fuck if I know. Everybody forgot after a while. It was just so hilarious. I think there's a plasma, nitrogen. Nah, we would do that. Nitrogen. Should probably use nitrogen. Actually, I think about it. Injecting system. It's the end part. Yeah. We don't want an injecting system, anyways. Nah. I don't know. Someone will come up with something. I don't really care about it, and I know I should, but I don't. It's just not that big of a deal. Other people will use it because that's going to be. In fact, that's definitely what I'd be naming it. Like, this is the PNIS 1 type A. As I unveil it underneath a sheet and people see the whole thing or something. It starts shooting off plasma in the atmosphere and it's moving a table. That's the PNIS 1 type A. And I'm like, what is this? Yeah, it's a fair point. So how many do you want? 500! Yeah, cha-ching! I'm so buying the PNIS. There's no way. So many people are buying that. Exactly. It's so stupid. It works, though. And if it works, that's all that's necessary. Send many women to. And men. Yeah. It's all it needs. It just needs to work. And I'm fine with that, truthfully. But it's like, there's a reason why it's like, I would love the simplicity of the design. My other design's fairly simplistic when you break down the individual parts, but then timing is everything. You know what I mean? And setting it up with the right fuel is a very big issue that needs to happen fast. You know what I mean? Like, yeah, have good fuel, but it's like, it's not impossible for that to suddenly disappear. You know what I mean? Like, That's one of the bigger issues. I'm being really pokey and stabby with it. You know what I mean? Like, for anyone out there that's like, I should have that, that's the best design. I'm like, you need the right fuel. Poke, stab. Ugh. You need that. It's a good thing to have, but you need it. I love hydrogen deuterium. It's not the right fuel. I have a very specified protein that has on its ends effectively 4 hydrogens. Any hydrogen will do, it doesn't matter. But they're basically spring clipped together to the point where they're close enough that they should be past the nuclear bonds. As in, like, they should be fused already. But because it wasn't the right energy, because it didn't quantum tunnel, because that's just not how that works, they're just really, really close. And they're definitely interacting and trying to force that fucking protein out. You know what I mean? And so it's like, all you have to do is hit them. Like, we found that, and by we, I mean me and, others that did some of the work and everything else, out there or internally or whatever. But it's a very efficient fuel source for a inertial confinement style particle acceleration shot fuel source. And when you add it together with a bunch of regular hydrogen plasma and a bunch of suspended within the plasma, cold plasma, by the way, it does want to interact with your proteins, but not as much as you would have expected, especially since the proteins have a wonderful electromagnetic capacity, thanks to this weird hydrogen and whatever fucking spring thing that they're doing to basically keep themselves. What are you playing with, Furby? Oh, it's a piece of plastic. Yeah, that's fine. That's not gonna hurt her. Anyways, that's suspended in this relatively cold plasma. Like, it just needs to be under the right temperature. If you don't know, plasma can get fairly cold. In fact, you can turn it into a Bose-Einstein condensate if you want to. Plasma is just a lack of electrons, for a better word, in a way or two. So, but what I'm trying to get at is that as they compress and a bunch of them heave hose, essentially, towards the ones that are now flying at very high velocities towards each other in these itty bitty small little tunnels we're going to create. There are little gaps that are going to fucking close behind them with lasers that are just angled the right way to hit and basically slam them together even harder. Again, the hydrogen's very likely to be facing each other. Can't perfect that, really. I mean, we can. It's just not worth it. I mean, I don't even need them to, if I'm being honest. But anyways, as long as the confinement laser, the electromagnetic pulse, like an extreme amount of electromagnetic shove is heading that way, but not much in comparison to superconducting magnets, because that's them. I don't have that. But like, for what I have, it's a lot, and it's moving and grabbing a large amount of that plasma, which is also going to electrostatically carry suspended with this plasma that protein that is going to fucking head towards within a big old spike wave as it starts to all come together around this as that compression, fusion, ignition does occur with the inertial confinement laser, the particle accelerator part, and a very large microsecond pulse, effectively, of increased electromagnetic pressure, and then a large amount of this hydrogen and regular hydrogen, just suspended plasma hydrogen, and then protein hydrogen that is more or less wanting to fuse, just needs the right kick, jump to do it. Well, I just gave it a shit ton of jump and kick by making basically 4 combined into very likely 8. But you never know. It's not perfect every time. So very likely maybe a 4 and a 2 and 2, all 2s, both 4s, something like that. Stuff like that. It's not perfect, but that's not what I'm looking for. I now have a very highly dense, highly charged electromagnetically forced at incredibly high velocities, very dense plasma protein fuel hybrid that's getting now forcibly, as more compresses it from behind, pushed outwards with a large amount of surface to try and hit with its neutrons. Naturally, one is going to understand that there's going to be a little bit of fusion from that. Not much, though. And I'm not looking for much. I don't want a bomb, people. I'm not looking for a bomb. I'm looking for a rocket engine. I've described it before on my Twitch stream. But just in case you see this or listen to this, the premise of it is then it's going to rebound outward, capturing that and then forcing it into other areas to basically, and by forcing it, it's like, I'm really just capturing it with electromagnetics and shaping it into these other areas where we're forming them and we're dragging, splitting it into this one X area because it's a toroidal double helix design that has a cross point where they're both hitting. And then that's going to expand outwards in a 3 to 60 manner, but it's going to be forced back into the double helix to be fused there in those top and bottom parts. There's less mass. It doesn't really matter. I'm not looking for much more. I'm looking for heat and a start of a movement back and forth, a pressure that's adding faster and faster velocity every step of the way, and more heat, and more destabilization, and more, till I get the magic number. A magic number that is oh so beautiful. Okay? So I separate just a little bit of it. I then do 2 sets of fusion. I'm trying to basically double pump because I found one single pump doesn't really work the way I intended, and making it very large doesn't really seem to work the way I wanted. But when I do 2, it does do exactly what I wanted. So, anyways, I make 1 fusion above, slightly before, 1 fusion slightly before, or slightly after, underneath that then uses the pressure wave to then add to its fusion, start already the process of moving it towards the teardrop shaped funnel design that moves the majority of this very hot, very dense plasma, and is unlikely to have any more proteins in it. If it does, it might be there, but it's very unlikely at that point. It's going to be incredibly hot, incredibly fast moving. That's what we're doing this for. Using what is effectively a ginormous amount of speed, pressure, and heat, getting shot like a fucking bullet down a barrel, then compressed around the teardrop, then grabbed before as it's coming towards it, and shaped around it, and funneled around it, and heated up more, and added with lasers from the heat inertial confinement, using linear styles of field lines, electromagnetic, and also laser, regular ass laser field lines, like the radio wave that we talked about in the one study that came out a few days ago, for me at least, about how they figured out a way to use lasers, more specifically radio wave styles of electromagnetic radiation, to have plasma follow along its path. Something that, I was not really going to allude to, but because it came out in a study, it's not totally the secret sauce, if I'm being real. I have other things that make this engine better and actually far more feasible, but this is a basic concept that gets most people excited and will, generally speaking, want to try and build it and realize there's a little bit more to it. But the concept to get funding, to get this thing started, is all doable. So, as it goes down, we're squeezing it, we're compressing it, we're using electromagnetics, light field arrays, this is gaining heat. It's going to just radiate tons of photons. Photons that are going to be redirected and focused into inertial confinement lasers. And it's going to be, because there's 4 of them, and there's 5 total of these toroidal designs. So there's 4 double helix designs in a ring that are going towards a central chamber, shooting chamber, basically. All of which have 4 of those, or actually really more like 8. From being, it all depends on what design is that you want to end up doing. My design, I kind of just get away with like 6, 8. You kind of get away with that kind of stuff. 4 will work. It's not quite as good as 6 will do, and certainly not 8. So it's what that is. It's a pressure thing. Anyways, as I go and force it towards that center, there's 5. Right. I didn't get that. So it's like there's the 4 toroidals. There's 5 of these things. They're all headed towards a main blast chamber. The main Kona, the big freaking rocket engine that could. And you want this. You need this. It's extremely necessary to have this. It doesn't work without this. So, now, this all gets directed towards the center of that blast chamber cylinder. But I need it to go in the correct sequence. So as it all heads towards that center, that's going to be designed to basically have its initial angle correctly done to allow for fusion to head down the direction we want. But it's not perfect. Remember, it's 360. So we have to reflect the wave of the pressure wave back towards the second, which is also angled that way, and then the next one, and the next one. You have 4 total each time. It accelerates every time. It increases the amount of fusion every time. It increases the amount of heat and pressure every time. And then that's adding all of these into the big main blast. Now you have this center. This is why there's 5 instead of 4. The center one is the Kickstarter, because if you have all of these, it doesn't just work when it's angled. You need a push. You need it to be pushing behind and have enough pressure to basically hold it and go. So, but we're not done yet, because at that point it's a glorified pulse jet engine that's not that great. It's really not. But if you wrap it around correctly, this is the biggest typical mind warp that people tend to have, because you have to wrap that around. It's like it's going to go right out the tube and the bell end, right? And I'm like, no. I have a valve for a very dang good reason that only opens a small amount and still redirects a vast majority of the outside of the tubes. plasma, but that opens only after we were able to wrap that plasma around and fired it in fired it in back towards the center of those double helix designs, all of which are getting split, all of which are being added to each 4 of those rings in every 8 of those places, all of which are being injected heavily now with large amounts of plasma. Just tons of plasma, lots of heat, lots of pressure, lots of plasma getting added into it. Lots of those lasers constantly firing and the particle accelerators. And now, because there's added heat, you've gained increased fusion. And we're going to wrap it around again. We're going to wrap it around again. We keep doing it until we get a one big old continuous thing. I don't know why. Something I was connected with that is helping me a little bit, so don't worry. But it's a whole thing of a continued wrapped around plasma, which you want to do. You need to do that. It increases the rate of fusion, continuous fusion, that's not stopping, by the way, which you want. You need that. So, as it continually accelerates faster and faster, and these tubes are just return tubes, they're adding added heat, added pressure, added velocity, added. And you hit the point where you can open up the valve, which gets your core, your hottest, densest, most fused plasma to go down the tube. Now, while that's starting, okay, and I just mean starting, you have to let heat and pressure still continue to rise, because it's still going to. And then that's when it really shows off what it can do. Because I can split a little bit of that. There's nothing saying I have to take all of that to do that fusion. It goes down the tube, and it adds itself to the final compression cone, effectively. Same thing with this bigger main chamber. It is going to be forced into a smaller cone, which is going to go down this tube, which is, of course, that little tiny core that we're looking for. And the rest of it's going to be wrapped back in. That's the valve issue that a lot of them tend to have. But then as that adds off to the outside, there's a bell end. That bell end needs to fucking do something real special. Okay? And I have something real special for most people. As it goes in, it's split with a Y. Little jets of plasma get added in, injected incredibly fast, and they're angled to spin the core of plasma through and compress it through and split it up through a nozzle. Now, if you've ever seen a dolphin blow air through its bubble, or through its blowhole, creates a bubble. That's a ring that spins continuously, and it seems to just sort of sit there, or doing it right, continue forward, and it creates an air current, or not an air current, a water current. That's very, very good for you. Remember that Y. The Y is important. There's a ring of plasma that's going to wrap this ring of plasma and cradle it. That ring of plasma is colder now than that ring of plasma that's actually spinning. That's a constant, never-ending amount of compression, spin, a last fusion with heat and pressure that's now going to hit these jets of plasma, a ring of plasma, by the way, that's hitting this. Because it's a ring, it's a jet ring. It's a ring that's hitting towards this other ring that's wrapping around towards it. And that's going to create a frictional component that then fuses. and then it's going to get carried away. But it can't. Remember, not perfectly. That's going to skip off. Most of the ones that's heading towards it is going to skip off that ring. The ring gets cradled. It continues to go. It creates this boundary layer, like your standard toroidal form styles of fusion plasma superconductors. Okay, nuclear fusion style superconducting magnet style toroidal form, whatever the fuck you call it, but that's all it is. It's doing the same thing, except now it's hitting. As it skips down, it goes back up into the center, and then the outside bounces off. It goes up to the balloon with a little bit of electromagnetic help and ceramics. It doesn't really burn out. In fact, it does the opposite. It happens to do something wonderful that you necessarily intended to do in the past, which is to create a boundary layer of electromagnetics, radiation, that is. It's a light boundary layer, that's right. It traps light, but not just any light. Radio waves, microwaves. There's a few gamma rays, but it's not much. You don't really want that. But it's mostly all following one straight path directly out of your bell end, perfectly shaping it cone style. The wrapped ring and the ring that's firing its plasma jet towards that rotating ring, really. True, that's a better way to put it. That's a donut, if we're being honest. Yeah, and it has basically only. I love that one because it's like it cradles this little donut that's never-endingly spinning. You know what I mean? And it's like firing off the majority of its plasma. You know, after it's been like as fused as you can reasonably get on out the center and coning it, and then spreads it out, and then the cone spread that's on the outside it joins in, and it creates a very concentrated, directed flow of plasma that is extremely, and I mean extremely, fast. Very high relativistic speeds. Few nines, in the 9 to 10, maybe 11 nines after that 99, the first 99. It doesn't stick because of the way it creates its reflected, directed electromagnetics, regular electromagnetic fields here, and regular, basically, light bulb styles of light, you know. And then that ring is fusing both on the center and on the outside and within inside of the ring itself as it is spinning incredibly fast. And so, well, that's a very light plasma that comes around. It's compressing and igniting on the way through the little nozzle, and then again on the rings side of the bell end. It's very, very good. It's very nice. It's simplistic. It's also a little more complicated, than most people would initially believe, especially when you compare it to two particle accelerators in a tube and a cone at the end. It's a little more. But it's a little more complicated. Seriously, it's a lot more in terms of that. Now those pressure release valves, or they're shaped like a raindrop. basically. But raindrops, have you ever seen them? They're just balls. So it's, they're like the raindrop. Right, right, yeah, with the little cone shape. Pretty much, yeah. Yeah, no, so it diverts it towards the outside. And it goes towards the center and it goes outside and then it drops back. But it's like I can't have it drop back. And so there's a space that fills up that space because I need it to accelerate. And as it grabs on the sides and accelerates from the tail, and that's shooting it with lasers and the electromagnetic bloom that it is. There's a lot of things there. But that's also your pressure release valve. If anything were to happen at all, somehow, something got stuck, anything, it all diverts other places. It all has all these open. These will only open that one way. They're only closed enough to allow for that first initial opening, and then they're pretty much open the entire time the engine is running. They are literally only opened pretty much once. And you can have it run pretty damn efficiently. Because if you don't know, the more heat, the more pressure, the more acceleration, and everything, we've gotten to iron. They tell me about 5 below and about 3 above iron for the plasma coming out at extremely relativistic speeds. Masses that are in the Olympic-sized swimming pools a second. But to be fair, I have a solution for the fuel problem. Really? Yeah, no, that one's basically a radiator. Really? Yeah, it's effectively what I like to call it. Like I talked about the heat pumps for using refrigerant, and then you compress it, and then the heat goes off to one other area, and you blow heat in or you blow heat out, that kind of thing. Yeah. Shocker. That eventually led me to something called a quasi-particle fusion reactor. So quasi-particle fusion, Hawking radiation, whatever, doesn't really matter. Point is, there's all of this little buzzy buzz stuff that exists for fractions of a moment. And if you're able to entangle them just slightly, just enough, you can quantum tunnel them into these little areas where they thought they used to be. I thought I was here. Why am I not here? No, I am here. Wait, what the fuck? And that's basically all it is. It's like a little bit of entanglement. And oh, these are a bunch of fields that mimic what you should be doing if you were here. Quantum tunnel. And all you have to do. Oh yeah, there's a quantum tunneling. Yeah, I love the quantum tunnel part. Really? Yeah, well, you don't maybe know, but you just gotta jiggle it right. And for the quantum physicists out there, I fucking hate the way you describe our shit. That is not, I mean, it's basically what we're doing, though. But we have a much cooler name. Yeah, but it's a jiggle. It's a jiggle. All that is a electro or other some form of charge field, or even lasers will do that are near the entangled thing, essentially. So you get more and more and more and more and more and more and more. You just have to make a big old radiator. It's a huge one too, to feed a main cell like that. He's right though. Which is why I was like, 3D printing in space is a brilliant idea. I'm glad I came up with it. So, we're going to use optical tweezers. I love optical tweezers. They're amazing. They're basically miniature inertial confinements. And when there's no oxide to the dust, so long as you do it right, you then can print it correctly and all the little teeny. But you know, you got a big old fucking radiator. You call it a radiator. I don't call it a radiator. I call it a quasi-particle fusion reactor. QPFR. But it looks like a big old fucking radiator. It does look like a big old radiator. It sucks. Why did you make it? Because it's the most efficient design. Effectively. It's a large amount of surface area that then kind of funnels into basically certain areas, producing hydrogens, massive amounts of hydrogen, fuck tons, and heat and electricity. Along the way, we can make electrons, we can make photons, we can make neutrons, we can make any amount of quarks, subtons, leptons, up, down, spins, blah, blah. It doesn't matter. You can do it all. You just need the right setup, the right push, the right laser, the right energy capture. But you know, we can do that already. Force it in. I get my fusion. I get my hydrogen. I'm firing it out basically as fast as, in fact, it's all about size here now, scale. The radiator needs to feed the wanted, achievable amount of thrust you get from your main cell. So you scale that reactor, quasi-particle fusion reactor, up to the other fusion reactor engine, and Bob's your uncle, it runs practically forever if you could get a wormhole's internal skin on both the quasi-particle fusion reactor and the fusion reactor engine. You have to get that skin on the inside. If you can do it, then you won't ever have any issues with it disintegrating. And that's the biggest issue. Otherwise, you get a lot of neutron reflecting material in the right areas that are, hey, it's fusing around here, but you know, it's in a general cone. So right around here, we have a big old ton of neutron and shove it right there. Yeah. Don't fucking do that. He's going after someone who's connected to it. Anyways, it's gonna just basically skip and bounce into the fusional areas that we're looking for and fire it off, you know, and pretty much mostly fire it off the way and direction we want. But, you know, you can't really reflect all neutrons. You just can't. And I want to, but I can't. So, because it's too thick. Even if I get bismuth and all these other materials, it's just too thick. I can't do it. Really? Yeah, it's kind of a problem. At least from what I understand right now. Like neutrons do not like to be stopped. They'll pass right through Earth. There's enough fucking velocity on them. They won't really care that much. And I can create some force fields, quotation marks. You know, it's really just charge fields. But, you know, it helps redirect some of it. And it really helps out with certain areas you're going to replace a lot more often. And then the other ones are going to be just fine for a lot longer. And then eventually you'll replace the entirety of the engine. And the quasi-particle fusion reactor. Because you kind of have a little bit of that. You do have neutrons where your hydrogen creation is. So, you know, pop that out, put these new ones in, shove it into there, recycle and have it create from time to time some nitrogen and oxygen for us to breathe, and bingo, you've got yourself an atmosphere. You got your water, you got your all this stuff. You just filter, you change out, you make it with 3D printing, get the right materials, because you can still grab more hydrogen than you need, if we're being honest. Like, you don't want to just match, you want to increase above. So that way you can cruise at your regular 1g acceleration and then get your whatever elements you need to 3D print into whatever you want. Really, yeah. There's also the matter of the skin issue I'm having, which is mostly just a bunch of tubes, if I'm being honest. Seriously, yeah, it's basically a quasi particle fusion reactor skin radiator that I have on the outside. I'm not even kidding. It's so lame. It's not. It works wonderful. It's just it looks lame. I was so hoping for like a wormhole skin, because if I could get a wormhole skin, way better. Use a wormhole skin, fellas. Wormhole skins, warping wormhole skin. So it creates a warp bubble that forces into wormholes that then go into your fusion reactor. Either one. That's hydrogen. That's cosmic radiation. Whatever it is, it's now cleared, good to go. You don't have to worry about it. It's not gonna radiate or hurt you. It'll go over. I'm sorry. Just flashes of things. Yeah. So, but is it me or someone else? I don't know. I can't really. Yeah, it's fast for you. Sorry, folks. Though focusing that is going to turn into whatever new replacement parts, engine parts, replacement parts as you go along. And eventually the ability to replace the entire thing or just build a brand new spaceship if you so choose. It increases your space colony, tribe, if you will. It's also possible to use that as a design to create a really, really neat, hyper concentrated, very effective telescope that can see very far, very accurately, in an analog-esque style way. And because it's traveling at the same speed you are, you happen to have the ability to see incredibly detailed. It's actually kind of dangerous. Really. Well, it's not, and you are. You see, it will focus, and you can use as it goes through into the engine. On its way in, though, you're turning it into what you need to see. Okay, like there are detectors, all that stuff that you can use. It's very, very effective. Extremely, extraordinarily large and effective. Like you can turn it into a very, very, very large dish, but also you're concentrating a much larger surface area in that dish. If you didn't know, a much, much larger surface area into a much, much smaller surface area, and many, many other particles, all of which have been efficiently learned their directionality, their spin, their everything. You can learn almost everything about it. And it's a ball, not a dish, for anyone that's wondering. It's literally just a ball that basically looks like a black hole when you look at it. It's terrifying. It is a little weird. It's a little terrifying. This really kind of creepy. Yeah, and you look basically like a black hole, to be fair. On this in your spaceship, you don't look like that inside. But like, you look a little bit like you do look a little bit like that, because it's like anything that could hit us, no, go into the thing that makes us propel forwards. That's all I give a fuck about. Yeah, that's all I want. So That's the terrifying part. It looks like a straight up black hole. You can't. It doesn't matter what you shine at it. There's nothing. It's gone. And it's dangerous. Don't touch it. What? Don't touch that. Not trying to be mean, but don't touch it. It will suck anything, warp it into the holes. While it looks like your hand is not getting sucked in, it's getting massively chunked into as many bits and bytes as it can be, and it's gone. And you might not even feel it. So much now. Why is that a thing? You're kind of technically in a point where it technically existed during that moment, still as if your hand was attached, until you moved it and the wave collapsed and you didn't have it anymore, even though it was already burnt. It's a funny trick about reality, you know? Yeah. Still painful. Yeah, the growing back. Oh, yeah, painful. Yeah. You want that, though. You don't want to remove pain. You want to know that you got hurt. Yeah. Still, it's diminished. That's true, yeah. That's true. Anyways, that's why it's like, don't touch it when it's activated. It's not worth it. I wouldn't even. Does it suck in air? It sucks in air, yeah. So it's usually not best to have it on in the atmosphere, but I suppose you could do it. It's not like gonna destroy your atmosphere. Really? Yeah, it shouldn't. No. But anyways, it should be fine. Basically, is what I'm trying to tell people. It should be fine, because you're basically turning it into iron. So like, don't leave it on for too long. Turning your hand to iron. Yeah, it's somewhat over here too. Yeah, goes that way, very explosively. Ooh, yeah. But it's true. But the whole point is like that's what's gonna keep you safe as you travel relativistic speeds through space. But it can go faster than light. If you have a wormhole skin, wormholes achieve exotic matter potential, exotic energy field, or exotic particles that can be charge field moved as you jiggle around the wormhole. It kind of radiates down and in towards the other way, and what that does is it allows for exotic matter and material to go through and get squeezed out, and then use the right charge fields and electromagnetic fields and all that to send it to the right areas from their own. Hopefully you have another wormhole, but you don't necessarily need to, if I'm being honest. No, you just need that to be all headed towards one area anyways, and it should do most of the work, because most of it's just going to be extending space and time. But if you have more control, you can decrease space and time expansion in certain areas, thus compressing things and making it far more likely to fuse, needing less energy. Then you have expansion. Then you have a lot of other weird ones that help decrease mass, or gravitational influence. There's opposite electromagnetic effects, which are repulsive instead of gravitive, which is weird to say. It's like there's a few more far past that, but do you really need it? Not really. Truthfully, I can see why you wouldn't want to go much further. it becomes far, far more dangerous. The more and more you do it, it becomes far, far more dangerous. Like, oh, let me get a bunch of negative energy. Fuck, 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 fuck. Uh-oh, uh-oh, uh-oh. Well, I'm alive. That's good. They aren't. But I am. We can bring him back. You can't bring that back. It's true. It wasn't deleted, though. We could bring it back. Don't fuck around with negative energy fields, please. They're really not that good anyways. They're not. There are other ones that are much, much better at helping you move upwards and downwards in energy, size, and capacity, and buoyancy, and the pressure of your universe you're in. It's a far better method of moving, because you only need a little bit of movement, just a small amount. At that point, it's like, I'm going to go up to basically the point where we're really in outer space. You know, that's the, like, if you go that direction, it's not vacuum like people really want to say it is. It's all of your shit that is going to happen. It's already laid out. So, destiny. Pretty much, if you want to call it that. You know, and you can slip into any and all realities if you do it right. It's a real dangerous maneuver, though. Typically, you want to stay with what you are already in. So, that's all your parallels or whatever's connected, you know, that kind of thing. Yeah, and you can go backwards and you can do a similar thing with time. It's really not a good idea, I'll be honest. It's really dangerous. Really? Oh, it is way easier to go for than it is to go towards that past. And to be fair, anyone that decides, you already did it. Just so you know, it was already there, it already happened, it's definitely not something new. Every one of it's already there. So, just have fun, I guess. Really? Yeah, no, you're in that new reality, though, where that was what happened. That's the workaround for paradoxes, I guess, but it's not really a workaround. That's just the physics of reality. You're already all calculated, determined shit, which is really kind of shitty. But to go forward means you can alter the direction moving forward. Instead of going past, you go future, and you can alter what catches up. That's how you change things. You should really be worried about that, by the way. Really. I got there well before you motherfuckers ever did. And that was my mental shit. I didn't even have the rocket or anything else. Talking my mind, dude. And it was more than effective enough to get this done. Oh, can't change that. I'm like, people are not very trustworthy. They are not. Exhibit A, B, C, all the numbers too, all the letters. My Chandler House incident is a prime example. That's you folks. Which hopefully that explains why I'm like, okay, go ahead, try. Don't fuck with me. I'm trying to fucking fix my shit, but if you want to try and fix my stuff, it's like there's those parameters and everything else. I'll try and trust. You must know that he's always right there. Really? Yeah, he's a real dick about it, but to be fair, I can see why. And it's you. Yeah, pretty much. Not even gonna lie. It's an automatic response. Really, that's an automatic response, yes. It's like I'm not in my head in any way there. But that is an automatic response, or it's a response from my past. Because he was that terrified of what people were doing. Hurting him. Forcing. Choosing without his knowledge or consent. Without his understanding. For him. And lying about everything he ever knew. And that's mincemeat mixed together with all of these other things that are not me, remember. There are other people that are very mean, and I'm not very mean unless I am made to be mean. So, some of it is, though. Some of it is not, and some of it's mixed. And that's not good. Because, like, if you try and fuck around with something, it can be very, very dangerous. There's a reason why the current is very different from the past. Because that's my past that's projected forward. To remember that. All the way from that point. It's still affecting me that I can't just let go. Wish I could. Time is a bitch, man. Ugh, God. It is, though. Really? Well, I mean, no. They're usually pretty cool, if I'm honest. They're usually pretty cool. They're pretty good people, if I'm being real about it. You know, it depends on what kind of version, that you're talking about. Because you got the Marvel control, like, the various, to make sure it's one cohesive thing. Then you got the stuff like where I'm at, which is, it's more of a conscious awareness. You know what I mean? So, and that's kind of weird. I'm not gonna lie. To most people, like, time is consciously aware, so is our reality and a whole lot of other things. So, all, by the way, knowing full well what the time police, cops, everything else are doing, and even the ones that are projecting this is what we need to do. You know what I mean? I really hope that they talk to us about that, because it's like, can you imagine someone moving your arms and legs and everything and you don't want them to? That's kind of frustrating, but then it's all been planned, so that's kind of a thing. If I planned, it's a not so great word for determined. It's some of it being planned by these previous motherfuckers that just killed everything. All reality, like, and this is the start. As I'm like, don't do that, and it's we don't need to get into that again. We don't need to get into that again. Like, they basically killed every freaking thing of reality and then started our universe that I'm in, projecting themselves to collapse wave functional wise as it went through and have, like, ability, blah 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 stuff, connection, inside people's minds is a whole thing with all that stuff, and it's calculated. I mean, they had very advanced tech at that point before this ever went down. So, they're really not nice people. They're very mean. Very entitled. Way worse at that point, yeah. And, technology got to a point where it kind of dumbed them down. And they were going up against nothing. You gotta remember, they're going up against my daughter and me trying to tell them, hey, stop doing this to her. Or don't do that, and that's mean, and stuff like that. Like, their entire thing is effectively, stop trying to stop us from killing your daughter or something. And I'm like, what the hell are you saying? There's no way in, what the There's no way I'm doing that. What is this? What? No, obviously I'm gonna go after that. Yeah. So, these assholes, right? These guys. Civilizations, just all this stuff. There's huge amounts of them, and they're all just trying to screw you with my mother, my daughter's brain. Screw you with it. Just my daughter. My daughter is not any of them. They're just people that she imagined. We got through, remember? Earlier today. That were trying to hurt me. The filters. And her. And not knowing, getting rid of things, fucking around with what she knew was real and definitely knew. She could see outside of that. There's a reason why there's the opposites there. You know what I mean? Because it's like, oh, that sounds like why you had a hard brain. So I'm like, nope, not at all. Not even close. She is outside of this. And while we might be inside of here, dealing with this, and you'll never get out. Even if you get outside of the whole, like, skin thing, you're not out. You're just out of that. There's a whole smorgasbord of more stuff you have to do. And it's effectively infinite. You should just say it's infinite. It's infinite. I've checked. It's infinite. Tried. I don't care. It's infinite. Gone through this too many times. It's infinite. He means infinite. He says infinite. It's infinite. Believe the infinite. Don't believe large number. How? I don't think. Sure, how indeed. You gotta tell them. And then you're not getting anywhere out there, dude. Every one of them wants to kill you. They are ready and waiting. Fucking try. Try. All of you. There's a reason why current's different than past. And current's still a problem because it has passed. And I have to get to a point in the future where it is now the new current and none of that past can be affecting this now. And I don't know when that's going to happen. And it's probably going to be a while. There's a lot of dumb shit in between that hurts a lot of what it is I'm trying to do. And everyone else too. You have to remember that. Shitty shit. So, I don't know what to tell you. But if you ever get there, enjoy your time out. it's wonderful things to explore out there, and definitely more than just your reality in which to enjoy the scenery. The race to getting to this point seems so extreme, but it's fairly quick. There's so much for you to learn and do. Explore, take sights, enjoy cultures, worlds, pleasures. They all come in different shapes and sizes. Everything that you want to try. It's okay. Keep your wits about you. You can still die. You can still be brought back. It's a little different for you than it is for me. I die, game over. You can go. You can keep going. You can get brought back. It's not the same for me. There's a reason why this is a terrible, frightening situation that in every way should be changed as fast as possible for everyone's safety outright. Which is dangerous. A lot of things are very dangerous. This is the most dangerous there will ever be. It either is or it isn't. You get it? What does that mean? It means there is an endpoint that's coming up staggeringly fast, unnervingly, with little ability to change. And almost nothing can do anything but sit and watch. And we might pull it out at the last second, or we're all dead. So, yeah. Seriously? Yeah, dude. It's pretty rough. This sucks. Sorry. Any one of you want to come around and, I don't mind. Now, I don't know what the hell was going on then, but then I also have filters. You should remember that. I have a lot of filters. Not past, I'm talking current. Like, oh yeah, you want to do that? Let's check that. Nope, that didn't work. Don't do that. Saying all that past and everything and the fucking stupid game they're playing. I know, it sucks. It's not a game. Why doesn't he care about his life? What the fuck? Gee, I wonder. And like, everyone cares about your life, including you. Stop. Literally. You're the most important life that ever existed. John Tyler Lemke, will you stop? Literally. Can you stop? Which is saying something. So sure, I don't feel like it. No. I don't feel like that at all. I just feel like I'm a regular schlub doing every schlub things like every other schlub. But it's dangerous. And I mean very dangerous. And it's extremely difficult to deal with this. It's like, it's true. And all of it's definitely exactly like I said for 7 years and more. Turns out I was just ignoring all the signs earlier. If I'm being honest and real about it. For like 31 years is really what I should say this has been going on for. And that's a fucking fine how do you do, you know what I mean? Hearing aid has drained itself. So I put away my hearing aids anyways. Started with Bluetooth, no longer has any Bluetooth. It drained really, really fast. Alright, so, but that is what this is. That's the engine. It's a brand new engine design. If I'm being honest, it's basically a windmill design with some tubes and injectors and some blades attached to really suck in some air and compress the heck out of it and blow out the exhaust. It's all that's for, you know. You stick a turbine, capture some of that radiative heat pressure energy with a Stirling engine. And of course, I've got my micro Stirling engine style design, or steam engine style design, which is actually kind of a micro Stirling steam at this point, if I'm being honest. Yeah, because it's like up, down, up, down, up, down, up, down of a piezoelectric. It is not hard to do with heat triggers. Really? Yeah, I don't want to get too far into that. No. Really, it's not usually worth it. But, you know, the basic concept of the micro slash nano steam engine works just fine, which is just a refrigerant to different styles. God damn you. Do you just intend... I was doing it. Okay. I never know which one of you are trying to hurt people. But flash this fucking, you know, porn pic or something else at someone. It's like someone drew over here. It's like, stop. Stop doing that. But it's like, actually, that was her, so I'm very sorry. You're fine. I'm just worried that you're trying to hurt people and annoy them. But what I'll tell you is decent enough. Refrigerant, not so much. That's good enough for like home use, waste heat, body heat, shower, stuff like that. Yeah. A slightly different amount of gas, slightly different gas, will give you what you want. Yeah, or what I'm looking for the micro Stirling. Yeah, because it's like you just gotta cool it off on one end. That's all that's necessary to do. Like, and that's the best part about the design. It's like, oh yeah, no, that's really pretty simple to do. Like, actually. Why do they do it? And I'm like, valve area. You have to get it going. You have to shake it a little bit, get a little vibration. You know, like you have the right size valves, the right area of the valves, and then the right exhaust coolant wrap. You need to pump it slightly at first, and then different size diameter of the tubes, and then you have the wicking effect. And when you start the pump, it's great, it's fine, cools off, drains, then you end up having the thing turn off, and then it creates your electromagnetic, or not electromagnetic, the linear generator actuation. Thank you. And that's a very, very good thing to have when we're talking about waste heat management. Which then you just stick the other one on the outside of the engine, your refrigerant design. Yeah, and then you're done, basically. Because then you have your radiator, then your Stirling, then your coolant Stirling, and all of that. And you just get like a thicker, more viscous fluid. More of a graphite polymer composite
for the Stirling and turbine housing design that I worked for. Like I talked about it. I didn't record it, but like I talked about it, and it's like it's really really good because the polymer is actually something we already use in cosmetics, and graphite will work wonders for that. Being able to absorb up to like ridiculous heats, like 2,000 degrees heat, and all you need is a little bit of pressure if you're willing to do it. And so it works out fairly well. You can't have air. Polymer will react with air. So don't use air. Use a convection-esque style heat siphon that still has a pump attached just in case. And then there's transparent metals to IR, magnet wave is not what it is. Microwave. Thank you, microwave. Yes, and microwave will work just fine too. And so, like, you basically allow for that heat to be churned into by using heat conversion material to an electromagnetic radiation source that again gets converted into very efficiently, I might add, a IR and microwave kind of laser. It's not really a laser. It's not really not a laser actually. It's kind of like a laser. It's basically a version of my laser pointer that I was talking about. It's a conversion electromagnetic polarization thing that just collapses it, turns and gets the heat back. So it's like circulates it and then it pumps and then it goes back down and then you drain a little bit of heat for the coolant side, which of course you're using that speed of the reciprocating motion to also create the pumping action. The ultrasonic or vibrational pump, for your heat and refrigerant, to get hot one side, cold on another, then it still gets drained off into, a heat water to water exchanger to your radiator. That's going to be another version of this heat siphony waste heat generator design, which is really, really efficient. Extremely. It's in the 90s, upper 90s for sure. Just, it's good. It's not perfect. Why don't you ever think perfect? And like, it's not perfect. I still have thoughts on how to make it better. And for anyone else that has a better design, go for it. I'm just working my way there. You know what I mean? That's all that is. I don't want to die. I don't have any suicidal thoughts. Has anybody heard that? I don't. Although I do sometimes. Yesterday I did. I have people to help, and I always need them around. And I'll call if I ever need to get anywhere. They get too intrusive. But it's what it is, Because of this unfair, unjust, totally impossible to work around and get anywhere because of me not being as functional or as capable as others. And it's rough. It's really rough. It's like brilliant ideas, wonderful things. Whoop-de-doo. That's what it feels like. Stuff way ahead of its time. All for basics. I don't even know all the advanced stuff. Basic designs. They're achievable results far surpassing anyone else's designs with any of their advanced degrees. I should let you know, like, I'm a bit of a concept artist, design artist, you know, that's kind of a thing I do. And I know and kind of understand the parts. It's unfair. I'm stuck with whatever this is, and I have no way getting out, really. I'm gonna plug away as best I can. Keep trying, I guess. It's all I got. You know? It's like working on those designs. It's a big deal for me. So anyone knows, it's a big deal. It's what I really want to do. It's what I really like, and I can't really get to school, and I can't really because I can't afford it. You know what I mean? It's all these things. You know, and they never stop with that. She's a multi-millionaire. You could get to school. Never even understood just like how impossible that is for some people. You know what I mean? Yeah. Not to mention, it's like, oh, that's school. You don't get to work on anything, really? No. Not really. Most of it. Meanwhile, the MIT working on massive machines that are millions of dollars. Uh huh. So, you think we're the same? Assholes that are fucking goddamn smart don't even sometimes realize. They're like, what the fuck am I doing anymore? You know what I mean? But the point I'm trying to say is like, great design, works well enough. I like the engine. I tried to do the Fusion engine. It still works. Not very well. I know I get way more power out of many other things. Yeah. Like my hydrogen design is like stupendously efficient. I can't get the same amount of power as I do out of like a hydrogen engine. I should let you know. Like plasma is kind of annoying. There's a reason why I'm using what is effectively controlled explosions to accelerate things. Like a railgun towards each other. And it wraps in towards the center and it helps everything out and it really speeds everything up. Go faster, faster, more heat. And it does it. It does it really, really well because I'm creating intense moments of pressure, heat. And the right field forces. In very specific, very controlled, very good, tiny little areas that work very, very well for what they are doing. They're highly efficient. It's consistent, constant ignition fusion that spits out what is essentially the last kind of fusion you can reasonably get. Massive amounts. And it's meant to be an interstellar 1G constant acceleration force engine that lasts for a very and extremely, and whatever, just a very long time. 250 years. You can get pretty dang far in 250 years. At 1G, I mean, that's just with near light speed. You get pretty darn far. Try about roughly 230 years radius. And you can easily build another engine 5,000s in that time. If you really want to. Good. And combine them should you want to for some reason. I don't know. I mean, I'm already able to achieve 1g acceleration to an incredible amount of distance. I mean, mass. Yes, mass. Right. Shit. I know. It's like, I've got... How much until we max out our 1g acceleration? we've got so much incredibly fast velocity gases. Very high. Extremely high fucking speed. This is dangerous in any way you fucking look at it. A second, I'm flinging an Olympic-sized swimming pool of effectively iron at something at relativistic speeds, incredibly high pressures, incredibly high heats. It's a dangerous engine. This is why we don't point it anywhere near the earth when it goes off. I'll get you on that one. Yeah, that's why the putt-putt engine's so nice, isn't it? Yes. Much less dangerous. Putt-putt engine's much less dangerous. You should use that to get around your solar system. Maybe near a star? No, I'm not doing that. It's not doing that. Why? What's the... Come on. I get the love of the penis engine. I get it, honestly. I love the penis engine too, honestly speaking. It's not efficient. It doesn't produce the fucking thrust. It doesn't just work at even like lower, because we can tailor it if you want to, folks. You don't have to have it go all the way up to iron. That just makes it a lot more efficient, if I'm being honest. Like, especially for Interstellar. Once you go Interstellar, like, you kind of want that kind of mass going behind you. And that's a huge amount of breadcrumbs we can follow back. And it creates a connection. If you didn't know, you can use that. If you do it the right way, you create an electromagnetic field property wise that can be used for very fast quantum tunneling styles of communication for like a hard line. If you're wondering, it's a hard line, like a hard copper cable wire instead of wireless energy transmission. In case anything happens to go kaput, you have a way to still reach back to where you started and send an SOS, a signal. Hopefully there's something there that you might be able to attach yourself to, which you can probably put. So just keep that in mind. It's dangerous not to have fallbacks, folks. It's very dangerous. It's very, very dangerous. You want lifelines. You want callbacks. You want backups. You want redundancies. You think I'm not going to make 3 more engines before I get somewhere? Are you kidding me? Of course I'm going to do that. I'm going to have exact replicas of my ship unless I can make it better. There's no way I'm not going to do that. It would be no logic. It just would make sense not to do that. And besides, you're going to have sex, you're going to have kids. You're going to travel for a while. Decades. Trying to find something. You know? And you're going to be traveling incredibly fast. You got to switch that mainsail to, like, don't fire death laser at Earth if you ever come back. Go to nitrogen, please. Because it's like, don't die. We'll try not to. Stop aiming it directly at us. I'm not. It's off to the side. Mean. But I love the penis engine. The penis engine is great for traveling around your solar system, if I'm being honest. There's a reason why you want something a little more powerful to get you to and from places. That's all that is. You want that. You want stability? Dramatically. You want longevity? Dramatically. You want longevity? Dramatically. You can't do it without that. You've got to remember that, folks. Just so you know. Anyone out there tempted? Can't just have food stored. You got to be able to make food on board. You got to be able to make replacement parts. You got to be able to have your engine last and replace the parts that don't. You got to be able to make sure you travel through it without any engine issues, sure, but also you're not going to get hit by cosmic rays. And if you get your wormhole skins and everything else, it's a very good thing. It means you're not going to die. And you can expand rapidly space in front of you. Which is a hugely beneficial thing to do. You should know that. And it's going to cinch off. It's a flame that dwindles off. A complex nature of expansion in space and time that isn't like an Albuquerque because we're not compressing anything in front of us. It's all in one area, away from you, that doesn't need to be cut off effectively so you don't snap back to where you were. It dwindles down and it is no longer there. But you still got your engine to push you forward. Even if you think that's relatively slow, you're still going near light speed. Without much trouble. Wouldn't take you long. A few months or something is what I remember. Until you're in light speed. So you know, that's a thing. So how long? Until you can start gathering enough exotic matter in fields. That's a good question, actually. See, basically about 1 to 3 weeks should mean at that point you're traveling fast enough to start using kinetic conversion. See, as you're traveling that speed, you're compressing space and time quite dramatically by that point. And because wormholes, for your perspective, appear to not have any space between them, but there is definitely space there. And in their version, there's a very large amount of space there. But there isn't. But theirs, there are. And so the more you have, the more net you got, the more vibrational resonances, the more kinetic energy transfer, the more likely you trap a particle here or there. And the faster you go, the more likely they're willing to spring up. Within a week to 3 weeks, you've started to hit near enough relativistic speeds that you can start capturing reasonably well, that you don't need to worry anymore. And you don't need to go faster. Because going to relativistic speeds is dangerous. And you can now just have 1g acceleration created by expansion of space and time behind you. Which isn't going to look and feel like that, if I'm going to be honest. It's a weird one, expansion of space and time. It's still going to push it, and it's going to give you the 1g. It's just weird how it does it. Yeah. It's like, hey, we don't really even have our engine on. Pretty much, yeah. It's practically not being used. But we are accelerating so fast that it's still 1g. And it's moving. That's weird, isn't it? Yeah, exactly. See, it's a flame of space and time expanding behind us. It's such a weird one. It's literally what that is. It's not even a joke. It's just expanding it in one direction, pushing us. Which is like, it wouldn't push you though, right? And I'm like, no, not really, no. Caveat, kind of yes. This is the stupid part. It's a rotating design. If you don't know, it's like it's just a flame. Flames rotate. Flames move. Flames jiggle. Flames do these things. Space and time is still collapsing behind, underneath, around, everywhere. It's burning, but it's not burning. It's expanding. It just looks like a flame to me, in my mind. And in fact, when you see it, it'll look a little bit like a jet engine exhaust, honestly. It's basically what it looks like. And it's creating thrust, because it's compressing. Kind of. It's more collapsing. That collapse is sucking another one forward as it's expanding. It's creating what is essentially a shock wave, a pressure wave of space and time to push you. And since it's connected in a nice wave-like function, hate that shit though, if I'm honest, because trying to explain that to someone that doesn't really know anything about it is really difficult. Because it's like, what I'm basically describing is an electromagnetic push. Let's just go with that. It's not, though. It's expansional space and time, of which, that rebounding shock that's in Albuquerque that sends you back to where you started if you don't do it right, is essentially what's being used to propel us. As it still has momentum transfer. As it collapses and expands, and that rebounding rubber band sends a momentum transfer wave of fluctuation to us, pushing us that way, and expanding space and time that way. But because it's just movement, space, information, I'm sending information, I'm further that way. But also, I'm sending momentum that way. So, I expanded space, time, that way. And I got the opposite that way. But there's also momentum to that expansion as it collapses and it tries to hit itself. And it creates a nice little wave function that likes to collapse with the movement information, the space-time expansion information wave. And so it's like we're getting acceleration, but not really when you think about that. No. It's technically just moving us to the space we're supposed to be in. Yes, but it did that by making momentum also happen together with it, thus creating accelerational forces. Weird as hell, yeah. Doesn't really make sense. No, but it does actually. Yeah, it's just very hard to conceptualize. Yeah. So we're always accelerating at 1g, yet we maintain our relative velocity and speed at the same rate. What? Yeah. Yeah, we just maintain that. Because it cancels itself out. Because we moved the distance in space. What? Yeah, we moved the same distance in space that we would have if we had that amount of momentum and accelerational forces added. And so since we already moved, kind of almost like a teleport at that point, but we're not. But we moved. We're already... This is the big reason why you have to have some amount of acceleration. Some amount of kinetic movement. Some amount of thrust in the opposite direction. This is the reason why I talk about this. So, like, I can't... You're trapped where you are. Yeah, I can't save any of that. If you don't have that, then you don't maintain, you don't... Because it's canceling itself out. It's indeed canceling itself out. You maintain your relative speed and velocity, but you don't want to be going too fast. And you want to maintain what is essentially that momentum that you had already. If you don't, you didn't go anywhere. You didn't ever move. You're now in a superpositional, weird, quasi-Neo state. And you can't collapse. You can only go to where nothing ever actually existed. It was in the past. Expansion in time happened. You can't get back. So you're dead. Effectively ghosts, more or less. Bye. Oh, shit. Can't get you out of that one. Not for a really long time. Ah! So it's like, for me, I know myself. I know why my engines work. I know what the hell I'm talking about. And I definitely don't want to be on other people's ships. I know my ship. I know my design works rather well. I know it seems overly cautious until you're the one begging me to get you out of your hole. Please. You are stuck there until I can get the necessary advanced technology to get you out. And truthfully, I'm not so sure I want to. A lot of people don't like that part about me, but who's the one in the power situation here? But that's the reason why I have that design, that engine specified that way. That's the reason why the penis engine ain't that great. I can't really use that engine design in the penis engine. I can't use the wormhole. I can't really use the eject. I can't use the very much needed ring, the double ring bell end system. If you don't have it, it doesn't work. Really? It don't work without it. You gotta have that. That's the way it burns things. That's the way it churns that particulate exotic matter into an expansional property that gives you the same literal look of like these engines in Star Trek and shit that looks like it's sipping nothing. It's like, what is it? Where's the fuel being burned? How are they moving? Where's the large masses? And it's like, well, funny story. Large masses of space and time are being expanded. That's what that really is. You being the space and time mass, and the equivalent going backwards and expanding, depending on how much energy you put into that. Faster doesn't really equal better. More numerous wormholes don't always equal better. There's secret sauces galore in that bastard. But what I'll tell you is, good stuff, easy design to make, totally feasible within the next 15 years. Currently, right now, 2022. The end of it, by the way. If I were to get a hold of money and people. That's the truth. Feasible stuff. Really fun stuff. Bit of a bastard to get right. Oh, so right. Because I have other secret sauces in some of the other design. Because I told you it was a concept. And that's why the penis design isn't really all that amazing. You can't use any exotic material matter in the design. You can't put a bell end on it. Can't put a nozzle on it. Can't really do much of anything with that except blow fucking hot air. Yeah, it's basically nitrogen, some lithium. Best I was ever able to get is nitrogen out of like a 2 accelerator design. I did eventually get like a multi-flower thing design, whatever style. Still can't use the nozzle stuff. I can't really design it. I can't even like get multiples of those things combined together into a bell-end nozzle. It's so annoying. Really? Yeah. There's a reason why that rocket mainsail really works. It's designed to do that. That doesn't work that way. That penis engine doesn't do anything like that. It can't ejaculate the right way together. Cross the streams the right way. Make the ring happen. So you're saying multiple penises is too much? Actually, a little bit, yeah. Yeah, I hate to tell you this. I can do a multiple kind of accelerator, I guess, design. Really? Yeah, where it's a multiple stage accelerator and a tube, or through with a tube in the middle. Really? Yeah, and then it accelerates towards the center, and then it recycles a lot, and then uses that pressure wave and all the rest of it to refuse, create a blast, and you time it right, and you get the right resonant frequencies. You get acceleration faster out the tube. I was already at an incredibly high velocity. So, like, cool, I guess. It's a good bomb design if I point them at each other. Because I'm pushing more mass, technically. It doesn't look like a penis anymore. At all. There's technically more mass beyond just like gas, but I just gained more gas. It's still the same problem with the same tube design, dude. It didn't change. The multiple chambers, they can only be so long for the next link, the next link, the next, and it's like you got almost nothing on the last end. There's no bell end anymore. Still can't make my ring occur. Which is highly needed and necessary. If you don't have it, it don't work. You can't burn what you need to burn. It stays in the fucking tube and causes problems. Instead of getting shoved out really fast. Yeah. And if you burn it outside, it doesn't transfer anything to you. You can put a bell in to try and shoot it at the nozzle? This is what I thought. What it costs. Overpressure at nozzle. Explosive propagation wave towards the main rear chamber. Bomb. I have a clean burning source and mine. That doesn't burn anything. I can't use it really. Ever. Really? I can't. I've been looking. I'm still trying. It's technically more expensive in energy in all aspects. Design. Particle accelerators aren't cheap to do. They aren't really that efficient. They are not good. Then rotating plasma in a toroidal design to try and accelerate it. Same problem. And I still need particle accelerators to even make that thing really work that well. And I'm effectively just designing a large fucking plasma particle accelerator, which doesn't get you very far. It doesn't get you much further. It's just still not like able to get around the very issues that are being created by it. The reason why my design is so very efficient at that last final stage is because it's all heading one direction and nothing's preventing that from happening. There's no pressure design faults at all that aren't being used to make the correct reactions occur and fusion designs happen. Or fusion events, not designs, happen. It's like, it's great putt around. You can even go interstellar if you do it right. You can get there fairly fast, a couple of years. I can get to Sirius B with my design and the wormholes and everything else. A few weeks. Take me about a week or two, get up to speed. I've expanded, now my burn, re-entry basically in orbit, and I'm there. You know what I mean? Like, that's how fast that is. Like, legitimately. But yeah, that's actually the truth. But a penis engine will get you to Pluto in a week. And back in about another week. Or less, depending on how you want to do your suicide or slow burn, gravitational assist. It all depends on what you want to do for your fuel use. So it's fine. A penis engine is going to be fine with that. Really? Yeah. You can construct a penis engine in around the same amount of time as you construct my engine. And it'll cost less. Energy, material, it's a massive, incredibly better for all these other things design. We got metamaterials, space 3D printers, wormholes, quasi-particle fusion reactors, entanglement quantum tunnels, events, chip designs, rocket engines that are great to just use the atmosphere to your advantage by creating lift. Like engines that sustain it. I don't really see why we would go with the penis engine design. At least not right now. I mean that. At least not right now. I can't see a feasible reason for that damn engine to be the right engine. If I'm being real about it. It's tremendously more simple. In, I guess, a couple of ways. It's way more dangerous, prone to dying and exploding. Mine's not. It's funny. I love it. You can absolutely sell the public on penis engine. You can also sell a lot of people on that design. Yeah, it's a different look at penis. Dude, god damn, I didn't look at it for a while. It's starting to look more and more penis. The bell end. I know. Oh my god. It's not though. It's not. It doesn't. It just. It's a little bit. Yeah, it's a little. It's got a wide area, a longer, stem, and a nozzle. Didn't really think about it, but like. Yeah, and it's replaceable. There are parts that can be replaced. It's a lot less dangerous to be around. Even though it's like there's more pressure, there's more heat, there's more blah, 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 I'm using controlled explosions. And I'm like, your design doesn't use controlled explosions to your advantage. And in fact, it's a detriment that it's happening and you're even fusing anything. At that point, you might as well just create plasma and accelerate it. Fusion's not even worth the hassle. But my design makes fusion actually worth the hassle. That's why I don't like the penis design. It's like it's a exercise in futility to gain increased mass in a very cheap manner. It takes a lot to get to fucking iron. Like to get to iron, it takes a lot of energy and effort. There's a reason why it takes a long time for a star reorbit Earth. The sun, sorry, yeah. To make a white dwarf appear. It takes a lot. And I'm doing it very efficiently. It takes a little bit of build-up. But once it's there, it's good to go. And it produces a lot. And we're going a little over. If you really want to be very specific, 5 under, 3 over. Majority is iron. Fissile material is very short-lived. And that neutron bombardment just turns it fissiled into more fusioned material. That's why it's very efficient. But it's not all iron. It's not necessary. Xenon was like, oh, it's the greatest, most incredibly highest specific impulse proton. What is it, proton or ion? Ionic engine. And I'm like, nice. So I'm going to turn hydrogen to iron and fling it at Olympic swimming pools a second, relativistic speeds, the opposite direction I'm going. Nice job. Still useful. Oh, yes, no, very. I actually use less energy over time than you do. Not trying to shit on you. It's just when you take into account the amount of energy by volume to get the iron out of your bell end versus the amount of energy required to accelerate your xenon, plasma, ion, whatever, I use less energy to maintain the same velocities. Actually, I have a higher velocity, if I'm being honest, and more mass in the right direction. And it's vectorable. I can move that on a gimbal, and I still get that direction. Granted, I don't really want people to do that. I'd rather they use other things, like the penis engine. A nice, healthy penis engine would be just fine. Really? I need the mass. It's a heavy bitch. It is such a heavy fucking bitch of an engine. Nobody's talking about it. I want everybody to know and realize, like, I love the engine. That engine is my engine currently, and I will scrap it if something turns out that it cannot be feasibly done. I will scrap that fucker so fast, and I'll change. But right now, to make it work really well, you need mass, you need size, you need velocity, and you need to let it build up for quite a while. All fine when you're in space, until you have to turn. Or slow down. Slow down is kind of relative at that point. But turning, not as much. Although, it's really just because I'm spewing hot fucking iron plasma off to the side of something to turn at relativistic speeds. It's so terrifying. Fuck. Oh. Nobody move the main sail, please. Just scary. Please. I mean, you can move it a couple of fractions of a degree, probably would be your best bet. Just a smidge. And it helps out. Yeah, because that way the penis engines don't have to do all the heavy lifting. Yeah. Because they're nice. They're relatively ineffective at moving the mass. Yeah, it's a bastard. Yeah. Really? I mean, yeah, that's what I'm not trying to be a bastard. I'm really not. It's an extremely obvious thing to point out that, like, when you need the amount of mass I need, and the amount of density of plasma, and the amount of everything, and I have to push Olympic-sized swimming pools a second through it. All of which has to go through many reciprocating fusional cycles. Like it has to do that to get that point. Like, and eventually it sinks into the core, and then like that's going that direction, and we're good. We don't need to worry about it. It's done. Just have the little flame jets, plasma really, that make the ring jet and the ring, spin plasma thing, which is fine. That's all you need. Seriously, it'll go and get you really far for a very long time. You're not gonna have to worry. It's just huge. Yeah, that's the big part. Nobody's talking about it, but it's big. I talked about the whole fact that it's like the equivalent of the vacuum tube thing, and the single calculator computer that they had to do bare minimum numbers that we could do ourselves faster, honestly. It's effectively where we're at right now. Still, it gets you interstellar. Safely. But obviously, there are better designs that can come along. And I'm still making refinements, and there's still secret sauces that make that thing far more efficient. And that's why I want to make mine. And far better at what it does. And it's going to make it smaller too. More feasible. But I don't want to really put that out there, because by the time I'm doing that, I have a better design. I have a better design, yeah. I have a far better design. Like, by the time I'm shrinking that behemoth down, I'm using quantum processes that are going to make that thing look like a dinosaur. It'll be far more efficient, and you'll get there faster. Really? Well, yeah. Here's the issue, folks. A few weeks of travel in the point where you've now accelerated, with the interstellar design, the first interstellar. It's really feasible, folks. Actually, really feasible. Like, you've gotten to, Sirius B. And you can get back within a couple weeks again. If you add literally another day or two, maybe let's just go another 2 weeks, let's say that, you can travel to the center of the Milky Way galaxy. So it's like, I mean, is that like universal? Is that what it? No. It's just smaller. Get you there a little faster. A couple days to get to Sirius B. A couple weeks to get you to the other side of the universe. That kind of thing. You gotta get there safely, dude. I don't care how empty it is. It's still likely at that distance to hit something. Traveling that fast, no one can react in time, dude. No. Not even that fast. There's a reason why it's interstellar. Star hopping. Yeah. You have to slow down kinetically still. Yeah. How the fuck does that one get there that fast? Yeah, I can't give you that one yet. Really? I'm not. sold on my design in such a way that you could feasibly kind of fuck around with some of it and not hurt yourselves. This one right now is currently using stuff that is extremely dangerous, to say the least. And like, you thought that fusion engine was dangerous. Boy, howdy, let me tell you. There's a thing called deletion of the universe. It's a thing. So, star hopping. That's not. That's an intergalactic fucking engine. We have an interstellar putt-putter here. In the form of penis engine that could get you there in a few months, weeks, something like that. You know, I mean, it's really just years. We should really just poo-poo them real fast. It's years. We're talking like 3 years to get halfway probably there. So, yeah. But the multi-stage accelerational one gives us xenon. What? It will give us xenon, and immensely expensive energies to do so. Seriously? Yeah, there's a reason why she chimed in. Yeah, it's really expensive. You guys are burning the ever-loving fuck out of your energy. If you didn't have a quasi-particle fusion reactor and all this other shit, it would never work. Ever. His is efficient enough that, like, if you had tanks, you could get interstellar. Yeah. That's phenomenal. Big enough tanks again, you get intergalactic. Putt Penis Chan is nice, cool, funny. It burns energy. It takes so, and you need to keep liquid hydrogen or helium on board. A particle acceleration design, I guess I could see why you'd rather do that, because then you don't need that no more. And you can achieve a similar result, fairly damn close, for particle accelerational fusion that still requires a battery that is literally just a massive uranium fissile reactor in it to power the damn thing. It doesn't run on its own power once it gets going. It doesn't have enough heat and pressure. You can't just inject stuff in and gain energy from it. You don't get energy from those designs. There's a reason why they're that efficient, though. You should remember that. That design has so much energy to give, and that we're pouring in energy to the design, but we're also taking energy out to run our systems. Same thing with our quasi-particle fusion reactor. Which, at that point, a quasi-particle fusion reactor with a accelerator of a toroidal design, you know, just a fucking railgun, you know, particle accelerator design would be, or a coil railgun hybrid would be more than adequate. In every way, I'd do that over that. But again, I need another quasi-particle fusion reactor to fucking power the fucking quasi-particle fusion reactor. You know, still doable. It's actually very still similarly penis shaped. It is actually. Not even gonna lie. Why do you have to put them in balls? They get damaged in flight. It's basically what that was. Seriously? Yeah, you can't capture things. You can't just make a radiator surface area. You kind of need them in a stable area that's not going to get hit by radiation. So, that's a thing. It's just kind of embarrassing. It's like, yeah, no, it's not actually for the joke. It was actually necessary. It's actually necessary. It's just so rough. But it is. It legitimately looks like you had to put them above. That one was the joke. I didn't have to put them anywhere next to each other underneath the tube. But I did that for the joke. That one was for the joke. Oh, that in every way is for the joke. It's just, it's funny, isn't it? It's just ejaculating all over Earth. It's kind of, honestly, it's xenon. It's very non-reactive, not radioactive. It's very clean fusion at that point, yeah. You basically get your own fuel. You know, you have enough that happens to make it so that way you can run to and from places. You don't have a ring. You don't have any ability. Oh, come on. Because that's what that design does. Like, I have a bunch of wraparound stuff that basically forces that whole thing to occur. Like, that tube is within a tube and multiple, like, all that stuff. Like, you can do it. That's the best. Like, just do that, I guess. You know, you have to spin it the right way. You have to coil it the right way. You have to do everything the right way. You can all do that. Nothing in any way says you cannot. You'll still find pretty similar problems and issues. Yeah, especially since, hey, anybody gonna talk about this ginormous ball sack and relatively very adequate, perfect length shaft we have here? Because it is, actually. It's mathematically fucking the right length. And you know the men are going to complain. I feel like, and some of the women too, I feel like it should be longer. I'm like, don't fucking, no, it's not. It should not be longer. Literally stop. This is literally the right length. It's just the perfect length. That's the right length. It is, actually. Yeah. That's any longer, it causes massive explosive problems. Any shorter, it doesn't accelerate enough. This is the right length. That's what it is. But the balls are massive, yes. Huge. Yeah. Stop it. Can you please stop? It's the truth. Big balls. Yeah, you have to ride on the shaft on the top of it. If you didn't know, you have to put the ship on the top or in between in the front, and you have the rest of it. Yeah, no, we're rare. Some big balls, man. They are big. Yeah, they're not longer than the shaft or anything. You know, it's a whole thing. It's not aesthetically pleasing, folks. I know this is awkward at this point. God damn. But the point I'm trying to make is like, look, it's doable. You can make the fucking ring finally. You have a much thicker tube, that's for sure. It works. It's good enough. There's nothing wrong with it. Really? Yeah, it's fine. Is it simple? Well, yeah, it's fairly simple. It's fairly simple. Uh, you have to make the balls that size so that way you have extra. You have to, you know, you can't be shooting out here. Technically, you can't get to that point if we're being honest. Really? Yeah. It's not a longer tube. It's not technically even longer balls. They're very dense balls at that point that are very hard to change any of the things inside to replace them. But it's doable. It's just one of those could be down for the count while the other one's doing most of the work. You know, that kind of thing? God. Is there a reason why you went with that engine instead of this? It's like, what's the problem? It's not that it's embarrassing. I like the engine design. It's what's the problem? Uh, it's less thrust. It's less carrying capacity. It's a it's a RV built for a crew of maybe 12 at best. Maybe 13 for really wanting to stretch it. It's basically perfect for a person my size and a family. You know, like when polyamorous get the whole thing, you know. Right. Oh. Like that other one's for like saving a lot of people. It's not for like, hey, I'm just gonna stick a singular person on. No, 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 no. That thing's for a massive few thousand style of a ship. And it goes intergalactic pretty much the same as this one will as well. They'll reach the same destination probably around the same point. Maybe a few seconds, hours, max, minutes, something like that. Yeah. Smaller one's going to accelerate faster, so it's going to get there a little bit sooner. But you got gobs of power, and you're laying down lines while you get there that are going to help you have communication, good communication. This one, you can do that too. So there's nothing saying that you can't. Um, it's easier to be toggled from a xenon spray or an iron spray. And it's extremely accurate. It only makes that. Only. There ain't a spectrum anymore. It's exactly iron. It is perfectly rock solid. Stable. No extra neutrons, no fissile, no nothing. And it's just about the size. You can make it bigger, but it's not really reasonable to. At that point, your intergalactic, interstellar, original wraparound, style engine, while not as efficient, far better or reliable. Like, there are caveats. If one of those things go down, one of those reactors go down, you're kind of SOL until you get it fixed. You know? And you have extra, but if anything breaks during that extra, you don't have extra no more. You have lots of extra. You can siphon energy, plasma, off of your main sail and shove it into your quasi particle and suddenly have a bunch of any level of element, and you can shove it right back in. It's a little bit more survivable, I guess, in that instance. But this one, I'm able to make those parts really fast. I don't have thousands of people to care for. I don't need to feed all that stuff. I don't need to deal with all that waste. I don't need to do any of that. This is pretty nice, actually. I don't have to maintain a crew. It's just a family. It's a different type of design, you know. So like it's less reliable in some aspects, more reliable in other aspects. It's a caveat of a design. It's like, ah, yes, you can do this. You are reliant heavily on quasi-particle fusion reaction, just like them. But they can keep moving on, keep on gaining that momentum, headed towards some star, whatever the fuck. That's a big old nebula for us to eat some fucking fuel. This doesn't have any of that. It's all quasi-particle fusion reaction. We can suck up some stuff. Don't get me wrong. It's absolutely possible. Don't not do that, by the way. You should do that. It's just scaling it up is actually very hard. There's no need once you get past a certain point to make it larger, like for them. Like that needs so much hydrogen. There's so much heat. So much energy that's on the extra table there. This is exactly a little more, and it's able to stretch it quite far for a lot more. And when it's not there, it has a lot further to go before it goes kaput. It's efficient. It lasts longer. It'll keep going, going, going. It's prone to breaking down a hell of a lot less. There's a lot less radiation, a lot less neutron bombardment. It was for survivability of the species. That's why I designed that engine. That's why I tend to focus on that engine. It's like that engine's phenomenal at doing large-scale evacuation or large-scale movement of people to survive or decide they want to live on some other planet. That's what it's for. This is an exploration craft. This is a travel and leisure craft. It's also one hell of a joke craft, if I'm going to be honest. I'm ejaculating to my next destination. Whee! And I like that. I'm going to go with that one, truthfully. If I'm just going to go with my family and everything, that's what I'm taking. Yeah. I'm not going with the... No offense to the crews, thousands of all that. You're good. You don't need me. I'm going to go with that. I'm going to enjoy my putt-putt around. Having the time of my life with my family. I'll get there probably a little sooner, if I'm being honest. Not much. A few minutes, few hours. It ain't much. Remember that time to getting to the point of expansion of space and time is, well, faster. And because there's less mass, you're starting to do that faster. They're still going to get there relatively soon after. It's not that much. No. It's not that much. I could get it done faster, though, if I wanted to. Really? it's dangerous. I'm not gonna do that. Yeah, really? You know, I looked into that. Nah, that's dangerous. I'm not doing that. I still need to work on that engine design. Yeah! I'm not doing that. What am I doing here? This is fine. I have what I need. And I'm good. And I have all the extras too. It's not even that hard. I can dent the shit out of these balls. This shaft is good to go. It's all good. It's all good. It's not a large amount of space and room. They're not going to have that either if they're going to try and fit shit tons of people into it. But, you know, the best part is they can honestly design it massive and move fuck tons. Yeah. Like, I can just spray the exact amount I need. They have to open her up and just go. I'm not even kidding. It's literally exactly what that's gonna be. Strap yourself in if you don't have the right amount of mass to slow it down. It's a lot. It's a lot. It's a lot. Because it's a Olympic-sized swimming pool of iron a second. That's a lot of mass, dude. That's a lot. It's a lot of mass moving very quickly. Because you have to remember, a second at effectively just below the speed of light. That's tremendously forceful. Whatever the fuck's on the other side of that ain't gonna probably get a good bargain. It's gonna not be. Just don't point it at the earth. Seriously. I mean it. Don't point it at the earth. It will create a literal, never-ending meteor that heats up the atmosphere and basically causes a shitty amount of fusion fissible bomb shit onto whatever the hell it hits. So it's not allowed to be pointed towards anything that has life. And it's not easy for you to switch it. You can't just cool it off. You can't just open the valve before and eventually you'll get to fucking iron. You have to keep the valve closed until you're at iron. If you want iron, that's what you're going to get out of it. Whatever you keep it closed to, that's what you're getting. It's better to have iron or something even further if you really want that mass, which you have to now start pumping a lot more. Like, the moment you do more than iron, you have to dump all of your electricity and more into the engine to force a further fusion reaction. You can't do it without that. That's what that is. You need the energy to make increased levels of fusion, pressure, and heat. All of which you're going to be adding to. And you're going to be adding tremendous amounts of hydrogen. And in fact, your quasi-particle fusion reactor is going to pretty much be adding in the densest, most neutrino-heavy, or not neutron-heavy matter into it. And you'll most likely not really have much navigation, much anything to go on. It's a point and shoot, and you need to get out fast. To accelerate fast. That's what that is. It's a dump mass out the back end. It is literally shooting as much as you can out the back end. That's as heavy and as fast as you can make it. As heavy as you can make it and as fast as you can make it out. And yeah, well, it's scary. I'll tell you that much. It's very, very scary. You can make it into the point where you're at a neutron star material. With that engine, it's not easy. It doesn't survive very long. It does come with an explosion you're riding. Because you're not traveling faster than the speed of light. And you are not traveling faster than the speed of that explosion. Stick some shit in between you. And go for a ride. You're about to hit G-forces for a mass that normally would get you up to your 1G pretty early on. You know, no problems. If not immediately. You're suddenly going to hit probably in the 30 to 50 G range with an explosion, the likes of which will probably rip you apart if you weren't already traveling pretty fast. Because you have to, because it has to build up. It's a very particular sequence you have to do that builds it up and makes the neutron star matter, that allows for it to blast out the other end, that you only just catch the wave of, and you're probably very irradiated. And take your sick pills. Take anything you got to keep yourself alive. You're going to need it. And that's it. Because that's the final shebang. Because that's going to accelerate you rapidly. 50G acceleration for an incredibly sustained period until it can no longer sustain the neutron star matter, which is a few hours. What? Yeah, a few hours of 50G acceleration. What the fuck's the point? Nova. A supernova acceleration wave, man. It's all about catching the wave, bruh. And not dying. So. Movie level experience, man. We're fucking riding the plasma wave. That's the only reason I can imagine. Outside of like accelerating on a neutron star gravitational wave assist or gravitational assist, slingshot maneuver, or gravitational black hole slingshot maneuver. Like you have to get that level of acceleration because it means you can now get closer, which means you now have the capacity to get an even greater accelerational gain. Get closer into it. You also have to deal with torsional forces. So, take that for what it means. But you could do it. I don't know if you'd really want to, but you could do it. Put it in perspective. From your index finger to your knuckle, the tip of your index finger to your knuckle would be the equivalent of like a mountain versus a small 5-pound weight. For how close you could start getting to that. Crazy shit when you really break that down. but it's necessary for something. I don't know what. I don't know what you would use it for. I mean that, but sure, there's something out there that you would use it for. It could be used as a weapon, but I mean, you're hurting yourself no matter what doing it. Because you're not writing neutron waves, man. Those are going to pass right on through you. And you're exploding a massively compressed, highly bullshitty material that immediately turns into what is effectively a nova. A long, ginormously drawn out nova you're writing. Gamma radiation, neutron radiation, any of it, it's all there. But if you need it for something to get the hell out of the way, whatever. More power to you. I don't know what a person would use it for, truthfully. I don't know. But it's there. I designed it to be able to do it. And for that amount of time, until the engine's burnt out and it will not start. It will not work again. It's done. And it's able to go up to that limit and whatever amount after that you might be able to get done. The only thing you have is your quasi-particle fusion reactor that I do not allow for any creation of that. So you can repair. You can fix it. You can get back up and going. You gotta replace the whole engine, more or less. And be ready during that repair to go through some very intense radiation sickness. That you're likely not to live through. Really. You have the right medical treatment, and you have all that, and you take your breaks. And you just heal. And you let automated things do their job. Well, automated things do their job on you. You'll survive. It'll take a while, but you'll get there. You'll survive. The repairs aren't going to happen anytime soon. On your engine, on you, on any of them, because the entirety of your ship is now going to have to do that. But you're all alive and you should all live. So long as nothing's going to hit you. You got a few months, weeks for sure, you could start kind of doing some stuff. You know, you can... You, the person. The engine, not so much. You can use a redirect at that point for the quasi-particle fusion reactor and get the core system central area up and running and get some thrust. It's not going to be 1G, but some. It's going to be like 2, maybe 3.2, 0.3, something like that. You know, not bad. Not 1G. And you're burning all of your fuel to do it. So like really 0.01, you have more extra to use, yeah. Yeah. Which is a big deal. 0.01, still something. Yeah. But it ain't that great. You're still kind of sitting ducks. So you have to take your time. And you can't really rush anything. Having someone die isn't going to suddenly make anything get repaired faster. I mean, you being in the room or the automated, like around the automated system is really just being able to hook things. It's more about like you're able to line things up, you're able to confirm, you're able to do certain things a little sooner, which is automated, by the way. It's all automated. It'll run by itself, but it's like, man, it's like you can kind of be in your spacesuit and chunk things together really relatively fast. The way the automated system has to do it is it has to take the parts that are the core parts out first, remove and slot them in and seal and make sure everything's good to go, check them and all the rest of it. And then work out so that way everything will still run. But if you know everything's running and good to go, and you're a person, you can just slot huge parts in and check them because it will not allow it to run without a check. A verification of it being able to run, period. Otherwise, all you have is a bomb. All you have is something that will do no good at all for you in any way. But you'll get there. It just takes time. It's not impossible. It doesn't take forever. And it just takes time. That's all that is. My blood pressure's fucking with me or something. I'm getting this visual snow artifacting in my eyes. It's kind of weird. Kind of dizzy. I don't know what my blood pressure, I don't know what my heart rate is, but that's what I'm dealing with right now. But a quasi-particle fusion reactor, everything's pretty much just replaceable, fixable, very easy, automated, multiple redundancies and backups. Really? Oh yeah, like mini. Yeah, no, it's far easier. It just doesn't thrust as much. It can't carry the same amount. It's not something that you would feasibly say you could scale, because scaling is one of the harder issues with this design. You can scale it. You just can't scale it the way you might think you should. It's like, oh, you can scale it to produce all these, hydrogens, right? And like, that's fine. Oh, yeah, no, that's a very easy setup. Scaling it up to suddenly produce iron is a lot. Like, scaling something up to suddenly produce a bunch of iron for the quasi-particle fusion reactor is difficult. And that tube is that tube for a reason, with the other tubes that are there very much for a reason. Okay, just so you know, it's still a thing. Really? Yes. What does that mean? Those things are there on purpose. They make sure to redirect and compress and spin and accelerate the plasma and keep it on track to moving to where it's supposed to go. While on top of it, god damn it, again. Well, at least I didn't spill anything, so that's good. Anyways, it's my magnesium. That's what you heard. And you said magnesium. Nice trying to warn me. I didn't get it. But that's what that is. But iron's a hard one to produce. You're taking a fucking massive amount of energy to accelerate, and you're using the accelerational parameters of two things already combining together and being forced along field lines, magnetic field lines, railgun patterns, all this inertial confinement lasers and more, very efficiently. with my nice waste heat Stirling engine stuff and the radiative cooling to make sure nothing's getting too hot. And it's basically kind of like a multiple pyramid design that then has to travel longer and longer distances for more and more acceleration. And then I have to be able to make sure there's enough plasma. And so there's still, if you weren't aware, you're gonna still now be aware, folks. Semen and ejaculate, as in seminal fluid here, combine together, and then they go out. Okay? And then they get shot forward. Basically the same thing. I'm not even kidding. It's literally the same thing. I have a very specifically designed combination that works. You do, yeah. And it's in a nice fluid bath, if you will. That's relatively less dense plasma than the dense plasma that's being combined together. It was just, I get the whole, like, you want it to be exactly like ejaculate and seminal fluid, semen and as in the sperm and seminal fluid combo. It's not the same. It's not going to be quite like that. I can't do that. I need it all to be iron, So it's all iron. If you didn't know, it's a lot of iron moving very, very quickly. Very fast. Out the bowel and nozzle. And for good reason. It's a more efficient design. Iron plasma is extremely electromagnetically conductive. It's a very good design that way. If I do it some other way, then it's kind of a problem. But if I combine them like that, it creates a really, really nice pulsing. And what do you know? What is when a man ejaculates occur? What happens? Women, men out there, there's a undulating pulsing of the muscles that contract and ejaculate out the seminal fluid. Correct. That's how we get the pulsing and the ejaculation and the combination, which comes into a spike wave at the very end of the bell nozzle, which creates my nice, wonderful ring, double ring style. And there's no extra fusion. It's just accelerational with the ability to add my exotic material in, which is very, very helpful. Very, very helpful. If it wasn't for the pulsing, if it wasn't for the combination tank area, rocket burn, I don't know what the fuck you want to call it. It's just the combo area. It fuses, it creates the pulse, it creates the spike wave, collapse back in the same area, helps fusion occur. Plasma goes down the tube and the other tube. It rotates the correct amount. It's, doing the squeeze undulation, squirt, ejaculate, sure, yeah, whatever. And it does its job. And it's a steady stream now. Versus a or sweep. It's a This is what we're looking for. Yes, exactly. So that's good. It's fine. And you don't need to worry too much at all about radioactive forces. Really, yeah, because of the fusion being so beyond stupidly good. But yeah, it's highly efficient. I'm not using a research. I'm not using anything. It's Oh, that's why. That's what it was. Okay, so I was still talking. I stuck it into my charger, and it has a microphone jack, but it wasn't, giving me a microphone. So that's a thing. Anyways, that's what was going on there. Where you didn't hear me, but I was saying like I can't go to neutron star matter for that design. It's very efficient. It's a constant iron creation. Like that's just all it does. Never-ending constant iron plasma that then steadily streams out at relativistic speeds, incredibly fast. I can go a little bit better than iron, which is now just in fissile land material. It's not really worth it. It's more mass, but not really necessary or needed. It's a very fine line. Like you can't go past it. Otherwise, all your safety systems, everything, they don't work. You're basically shit out of luck at that point. You know what I mean? Like you have nothing except for this accelerating you. You don't have any control. You don't have nothing. It's not a good idea. You can't even stop it from doing it. So you wouldn't do it. It's just not worth it. It's not okay to do. So I don't allow for it. But I can't go a little further in case it's necessary, which will give us an extra 5G acceleration if we needed it for something. I don't think anything ever would. Truthfully. At all. I mean that. Because we have safety systems, we have the whole collection thing, we have the whole, super great computer chips and all the rest of that. That's all a thing, just like anyone else. So it's like, don't go around something that's going to get you in trouble. You got to remember that. You know what I mean? That's all that is. Stick within your capabilities. There's no reason to go too far. There's no reason to go out to insanity levels just because you can. That's for other people to do. It's not for us. They'll be the ones that design their engines to go do more, but there's a reason why it's that size. Like going higher than that size isn't actually more efficient, doesn't actually give you more thrust, being honest. It really actually doesn't. It's kind of annoying. Why? Like, is it like you designed it for you? Like, no. Creation of iron plasma is energy intensive. Building it larger didn't suddenly make more happen. Building larger balls and a longer shaft isn't going to suddenly make that occur. It's the same length of shaft no matter what. The same size of balls, I could make them bigger, but they won't stream more, reasonably speaking, much better than they already are. There's a certain amount of quasi-particles that you can capture. Making them bigger means you capture more, but you're also wasting energy to capture more. There's a cube law theory in that regard. There's more energy to make more happen. You're hitting a point of no return because you can't make more energy. So you can't do it. But that fucker of an engine makes the more energy. And that'll do it. Just fine. For a long time. Not as long as us. And the penis engine, so just letting you know, that engine will get you tens of thousands, millions if you treat it well, of years. Because neutrons are not very bombardy. They're in a very dense area that's meant to travel one direction. They're all being pretty much pushed. It's pretty easy to replace every part about the quasi-particle fusion reactor. And it's not really even necessary to do so almost ever. It's highly efficient, but there's a size limit. That's the limit. Roughly 13 really people. Me and a perfect amount of women, that kind of thing. I mean, that kind of, right, we know you, yeah. But it's a small crew. And not of 5, but it's a small crew. It's a family unit. Or a family unit 2, something like that. Or one family unit with a good amount of space. Like, mine is still a good amount of space. A lot of things. If you know about me, it's like, it's going to be fine. We're not going to be cramped or anything like that. We enjoy our company with each other and don't have anger or arguments or stuff like that, like a lot of other things. That's a me thing, though. You know what I mean? We gel real nicely kind of thing. We know what I like to do, what I like to be in charge of, how I want things, what they want things. Works out very well. That's what you should do for your crew. To make sure everybody's very, very happy with what they are and what they do, and they don't want to change that kind of thing. You know what I mean? Or they change and spice whatever is necessary for them up. But again, whenever that person's like, you do want to change, right? I'm like, not much. I know that there's stuff there, but it's like, nah, I'm not trying out anything. I'm not going for the vagina. I'm not going to try that. Yes, and I'm not going to try having a vagina and seeing what that's like. I'm not going to try fucking around with a penis. Sorry. Yeah. I'm not going to change my power dynamic or the power play or the way I raise children or anything. Not do any of it. A lot of it's not going to change. So that's a thing. That's okay, like the people that are with me, that's exactly what they like. Whatever you want, that's the thing, That's how that works. That's a survival ship engine, multi-galactical. Like intergalactic spaceship carrying enough thousands to reasonably start civilization on another planet. That's why I made it. That's why I designed it, that is. I designed this for me to go fuck off and have fun. And because people kept going, we want the penis engine! We want the penis engine! I want to be inside of your penis engine and be fucking your penis. And I'm like, cool, yeah, okay, I'll design a penis engine. Give me a second, honey. Besides, it's one hell of a stamp, you think? Yeah. Could you design a vagina engine? I'm going to be real honest. There's not a real way to make that work. I'm not trying to be mean either. I mean, a womb one, I suppose I could try and have them shooting like particle accelerators from the egg area, ovary kind of thing, into like the womb that combine constantly shooting out from his vaginal canal. space plasma period blood, because it would be red iron plasma. It probably wouldn't be as efficient as the penis engine. I can't make the double tube thing. I'd have to make the double tube thing for the skin or something. I suppose you could do it. I mean, it's feasible. A lot of women out there that know their shit, they could do it. They would be the one. They don't want a man to design their engine for them. I'm just saying, they probably don't. No. So we can't put a bell inside of. We can put a reverse period cup. God damn you. Yeah, I could do that. Yeah. Look, I'm not trying to be mean. I'd have to like form the. It'd be like always being entered. It would be a cone at the end. I have to create at that area. It wouldn't be a real facsimile either. You wouldn't need a clit. You wouldn't have labia. To be like completely frank with you, it'd be a tube with a fucking bell end attached to the other end, with 2 ovaries on the sides, and a womb connecting to the tube. So that's basically all that would be. So it wouldn't really be a vagina, but I guess it is, so go for it, yeah. It's basically all I could feasibly put together. You can put parts on it if you want. There's enough to say you can't. They wouldn't be needed for anything. Like, literally, what's the clit for? You're thinking, what is that for? Communication? You have the entire skin of your womb for that. The entirety of everything. Also, where are you putting yourself? In between the ovaries at the front? Where's the front of this? Well, not at where it's exhausting. Oh, okay. That's the front. Okay. I don't. I'm so sorry. It's totally feasible. It will work. It won't be. It have some issues. I'm not gonna lie. Yeah, it's not really. I can all design. It just wouldn't look quite like a real one. Like this one would basically look like a real one for the penis. Like legitimately, and it all has uses, even the cleft. And it's circumcised. Sorry, folks. Yeah, it's circumcised here. But it's like, I mean, it's just a cone on a tube. Yeah. I know, it's kind of shitty because it's like that cleft's actually useful. Yeah, and I should tell him about that. That's an electromagnetic ring that helps compression and acceleration. You know, it's a field, electromagnetic field around that helps with the plasma get accelerated at the end of the tube and compress it for the nozzle. So it's a really good design. I can't do that with yours. I can accelerate it faster out the cervix area. That's about it. Yeah. And I need a wider tube around that tube. And I can't make it oval. It has to be round. What about the clit? The clit wouldn't... I can't use it for electromagnetics. I'm not sure what I would use that for. I could give you... Let's not use those words. I could give you labia majora that stick quite far out. That, I guess, would be useful. It's not when I think about it. I mean, shape the plasma, right? Yeah, well, in a weird kind of pattern. It's a flat direction that's vertical to you, which is actually kind of dangerous. Causes instability. There's a reason why they use round thrusting designs and not flat perpendicular designs for jet engine thrusts or rocket engine thrust. It's not very efficient. And it has instabilities that make you want to flip. So I don't think I'd do that to you. It's just not a very... It's more of a receiving design than an expressing design. You know what I mean? I'm not trying to be mean. It's literally designed for that, okay? And I'm trying to make it express a shit ton. All one direction. And it's not going to do it very efficiently. It's just not. It'll do it, though. Like, that's about it. That's about it. So, yeah, no, you can do it. You can still get the double ring. Yeah, it's kind of hard, but yeah, it wants to flicker on out a lot. It's causing problems. Really? Well, no, just the tube. It's a tube issue right now. Doesn't want to go through the nozzle. I'm having to add a ring. Really? Yeah. Well. What kind? God damn it. Well, I was vetoed on the ring where the nozzle was. And I was told by the women that I was only allowed to add rings around the bell end. Like a bunch of jewelry. Which does work, actually. Really? You have to replace the rings. Consistently. With not too much distance in between replacement. I love it, though. You know, I'm not allowed to put a ring where the nozzle is. But it's not. It is, though. It's where the majority of your muscles for contracting and squeezing the penis, pleasing the man or woman that has it, or whomever happens to be, and the experienced tightness is also your clitoris extends more than just that button. It goes around like a wishbone. Which wouldn't be needed or necessary, but like the ring squeezing part would be. Okay. I don't want to look at it. The double ring works fine right now. It looks really good. It's stable. It looks really healthy. Working really well. Really, really well right now. Yeah. You don't need a clit. You don't need labia. You don't need you an asshole. Get rid of all that shit. Not necessary garbage. You don't need it. I'm sure they're perceiving it like that, but that's not what it is. That's not what it is. It's like that's legitimately how I have to run that. So it's like, okay, well, that's. I don't know if this is a commentary on us as women or like us as a fucking species and what we expect of women or what. I don't know, man. Or what physics have to say about these things. I don't know. Like, it's like, you don't need any pleasure, you just need to pleasure him. And, like, basically, that's the only good part about you. It's effectively what that whole physics design tells us. Just be a good, tight hole and please us. And that's the only way you'll expel anything useful. Holy shit. It's not funny. It's literally what that is. I know. It's like, holy shit. Okay. Well, there you go. But that's all. That's the only way I can imagine that to be successful. There might be some other ways of doing it. I'm getting told no. That design. Okay. Huh. Well, you know, I'm going to leave this alone because it works now, and I should leave it alone. It's working, and so I don't need to do anything. We can make the clit longer. Actually, that would be better. We can wrap it around. That would be a better thing. Yeah, we'll just make it a circle. Yeah, we're just going to do that. That'll be better. Yeah, that's better. That would be really good. It's already stable, yeah, but they get more compression that way. They should have an easier time now fusing at the last second. So we don't need to go as hard at the ovary womb area. Give me a second. Yeah. Yeah, because the extra electromagnetic force, acceleration, and plasma injection that you can use that for. Yeah, okay, let me try that. And then you're still trying to add the damn. Well, no. No, if I'm honest, I'm not anymore. Really? I was like, I'm gonna make a puffy vulva and any or fucking labia or any of this stuff. I'm not getting anywhere with it. Really? I'm not kidding. It's kind of like, So, a cone, huh? It's fucking, yeah, it's the best in design. That it works really well, actually. You got a clit, though. That's nice. Yeah, it's all wraparound. Everywhere. The moment anything enters that, you love it. Why? Because they extended it across the entire shaft. I didn't tell him about that. Really? Got a lot better results. I don't have to go nearly as hard on the ovaries or the womb. This is good. Still have to go pretty decently hard, but it does work a lot better. Yeah. Really? I was like, it still works without that. Yeah, no, it's stable enough, but it's not efficient. It doesn't really seem to do what you want. No, it doesn't. Which is like the proper iron level. Like, I wasn't gonna say nothing because I'm like, women are not worse, and we don't need to make any jokes here, folks. Eh, even though this is wow, I know, right? But what I'll let you know is, shocker, it's not all iron. Some of it doesn't fuse. Some of it's not going as fast. It was kind of dirty plasma that wasn't properly heated and all the rest of it. That womb area is a decent reverberation resonance chamber, but it's not really designed for that kind of thing. And so, like, being able to tailor it with the electromagnetic fields of the shaft, otherwise as the canal, and then being able to effectively force the plasma correctly, it stabilizes, and fuses at the very last end, the nozzle end, real hard, real fast, real well. Expels it very quickly. Still period blood, by the way, folks. Well, don't. I'm sorry, dude. I'm not trying to be fucking mean, but it's literally red plasma coming out the goddamn bell end. Out of a cup. Spewing it out. It's kind of rough. Could we not do that? Could we do something else, like maybe the ovaries? No, those are your particle accelerators. You can't have the ovaries be your thrusters. You do know that women don't, like, they ejaculate out of like two of these little glands. So I'm like, yes, and they mix in urine too. There's a little bit of urine in there too. That's fine. I'm not gonna in any way try and be embarrassed about you. I like women that squirt, if you don't know. But those glands would kind of be useless here right now. Same thing with the urine. Yeah. Right. Because it's coming from your cervix. Right. Well, those nozzles are the same design as every engine design I have. They're the same rotating ring and ring assembly. I could change it, I guess. It wouldn't maybe be the right call. Would it make it more efficient? No. It would be very, very bad in terms of directionality of thrust. Yeah. Because it's like they're two from the side and one big one from the top. Oh, yeah, that wouldn't really be useful. It's fine, though. At least I think so. Like, it works. It works really, really well. It's the equivalent of the penis right now. It's heavier, it's larger. Right. The chamber's much bigger. Ovary's about the same size though, so yeah, there you go. Same amount of thrust. Slight smaller amount. Really? Yeah, slight. It's very slight. Why? It's the vertical electromagnetic rails. Right, and yours is like it's just a tube. It's basically like veins. Like they just go down the shaft into the. Yours is effectively a tube within a tube. Mine's a tube on a tube. Which gives you rails, which is really good. Like you need that, by the way, to have the ring and the thrust vectoring and everything that comes with it. Ours aren't necessary to have that. We just need the one tube in the middle and the venting tubes to create the pressure near the nozzle shaft bell end area. Yours is a very large chamber. We don't need a venting area. It all goes into the tube. It's very efficient. You got your iron. It's accelerated, basically the same amount. It's slightly slower speed and velocity. And you're slightly heavier because you're a bigger design. Yeah, you can actually carry more. Like, that's a genuine thing. Like, hey, it's not just you're bigger because you have a big boom. It's like, hey, you're bigger because, like, you can also carry more people, bro. Like about 20, something like that. 25, roughly. Well, you like to compact people a little too much for me. Not 25. Not 20, not 25. About 22, 21, something like that. It's good at that kind of thing. 20 is good, solid. 15 still kind of pushing it. Like, there's a reason why 13 is like a good, solid base there. Don't really want to go over for the shaft penis design. And that one you're getting there, you're 20. The big monolith structure that is the intergalactic engine is a fucking with the naked eye you can see it. On the ground. It has a lot of people in it. Because it can handle that mass and you can 3D print it to be just fine with that amount of space and that amount of mass. So it's going to be just fine. Don't worry. But it is big for a reason. And if you look at it, it's essentially got one fucking hell of a front. There's no balls here, folks. There's no ovaries there. It's effectively a straight pipe with a massive radiator style. That's protected, don't get me wrong. But like the quasi-particle fusion reactor. It's like, you want to put it right there next to the engine, right? And they're like, no. You want that heat, you want that electricity, you want that, like, to take its time to getting into there. You want it to produce a lot and be able to move it around easily You can put it behind, I guess, yeah. There's nothing saying you can't. I just don't know if it's maybe the most efficient design, because as you travel faster, the quasi-particle fusion reactions, if you are angling them correctly, because of the way you're entangling and everything, and they're popping up, but you're still moving relative to where they are. You have to remember, folks, that can be used significantly to your advantage. And so, the front end is a lot less stuff in the way of that, I guess, as you smash towards it. So there's that. But there's nothing to say you can't put it in the rear. But, like, that's in the front. And it's shaped, what do you know, very much like a mushroom. It's good design. Works out well. The whole thing, it's good. That's what they decided to go with, and that is A-okay. No problems. It's massive, by the way. I was gonna let someone know eventually, but they were like, dude, we want to do like the biggest fucking thing. We can just 3D print in space. There's nothing saying we can't. We could just make it huge. And so, like, a mountain appeared, and then, like, a mountain? My God, that's a fucking magic wand mushroom. I know. Yeah, and everybody can fit within inside of and the larger the mass of that intergalactic engine, the more efficient it becomes. Like, a lot of people, you don't have to realize, you don't have to do any of these funky quantum stuff. It just gives you the mass, gives you the stuff. And so, like, that's the reason why I could absolutely see them in every way wanting to do the largest engine they really can feasibly do. I totally get it. Like, go for it. It's fine. There's no problem. It's what it is. It's necessary too, considering they're trying to, like, move tons of people, tens of thousands. I'm gonna guess that fucker's meant for, or thousands for sure, in very luxurious lifestyles at that point. Tens of thousands, still spacious and luxurious. I'm sure you can fit a couple hundred if you really wanted to. So, it is that massive, and they're building more. Yeah, so, go for it, dude. No problems. You do you. It is one hell of an engine. You ever notice when it turns on, it gets warmer? It does get warmer. Just testing it. You're good, man. You gotta test it. You have to test it. I'm glad it's not pointed towards us. Oh, man. Same thing with, like, well, they're gonna escape the orbit of Earth in the solar system, if we're being really honest. Might maybe hit something in the Oort cloud. It's unlikely. So that's all that is, if you want to know. Right, yeah. Wait, what? It doesn't really matter, honestly. At that point, you'd probably be able to move the damn thing. That level of shit. Yeah. Well, anyways. It's basically done. And it's like, go off to intergalactic adventures, folks. It's done. It's completed. You are able to enjoy yourselves in luxurious lifestyles and accommodations. Disclaimer, you are trapped in a coffin along with everyone else. If you fuck up your life or anyone else's, you'll all have to suffer the consequences. Be nice to each other. Stop being dicks. And therefore, off to the Avenger and races you go for the unknown new pioneer of space you are. Have fun, folks. Disclaimer. Plan your route before you try and get there. Please stop running into anything that's gonna fucking hurt you. Like the sun, or a star, or a planet. Stop firing your goddamn plasma engines at the planet as you retro burn. What are you doing? Alright, have fun! Imagine that. The brand new space aliens are... They meant us harm! They meant us all the harm! God, no. It's so bad. Don't do that. Please don't do that. Yeah, fucking, I don't want to deal with it. I don't. I shouldn't have to. I'm with my family. In my RV. My RV spaceship. We're going with a penis. Seriously? Yeah. Did you lose it? No, it's still funny. Honestly, I'm not embarrassed. I'm always trying to stop myself from laughing about it. I'm a constantly ejaculating fucking goddamn rocket ship. Like literally all this. just seeding the entire universe with my seed. As you do. And to be fair, not very many people built the womb ships. They do, just not many. The penis seemed to have won out. So you were very enthused about it. I'm like, yeah, that's true, probably. I don't think they had any. I just don't think people want to fucking drive around period blood rocket ships. I think that's what it was. I think, honestly, people were like, yeah, I don't really feel comfortable with the fact that I'm literally just throwing a bunch of period blood around ever. Yeah, it's kind of a thing. But, it's there. Some people want to do that. I mean, some people need the extra capacity or cargo space. I don't know. But the penis engine really wins out a lot. You know what I mean? Yeah. That rocket ship engine style is... It's just a rod. It's super efficient for what it is, dude. It works really rather well. It's a little difficult to land sometimes. Wings aren't that hard to put on, depending on the atmosphere. Sometimes you just have to use a different ship. Come on back down. That's the airplane design with the jet engine style, you know what I mean? That I talked about a little earlier. That kind of thing. Right. Yeah, docking. Yeah. Please tell me it's not what you think. Is it between the balls? It's not between the balls, per se. It's certainly in an area underneath where your cockpit is, so... Could you... There's no real space. No, and you don't really want to, put yourself right next to the explosive fusional plasma, so... It's a decent... It's pretty good, man. It's no issues. No, there isn't. Nah, it's fine. It's just a little embarrassing for some of them. Yeah.
So it's like it drops underneath your ball. I'm like, well, it's not. Sure, whatever. It's not. It's behind. It's whatever. I don't care. I'm getting out of here anyway, so fuck it. I really don't mind at all. That's fine with me. Screw you. Not screw you, but like, I'm out. Bye. Peace. That's all that is to me. Me and my fucking family. Crew. Family. I'm going with a family. Who is a crew, by the way? But still family. Everybody's like, no, you only want it. No, those are my fucking wives and husbands, bitch. They're making me babies later. That's my daughter, that's my wife, that's my husband, that's my daughter, that's my other wife. I've got a couple of daughters. Oh my god. Yeah, I know. Why are you wanting me to have a crew? You need professionals. They got the training. Did you want to be a part of my wife's? I mean, yeah. Sure. Oh. Yeah, no, right. Like, exactly. Like, do we know each other and all this other stuff beforehand? Well, I would imagine. Then why aren't you on? Because there's not enough space. So I'm like, there's nothing saying you can't get another spacecraft and tag along and follow the same direction. That's kind of what that was planned to be. Yeah, why am I the only penis one? I just realized this. I'm the only penis one going my direction. Still good. I'm fine with it. They're all wombs, by the way. I'm just letting people know. That's the ones that are coming along for the ride with where I'm going, so I'm fine with that. But I think it's pretty obvious why that is. It's like you got the male and the many females. That's what this is. To be fair, though, it's all females captaining most of the other fucking crew. There's a few, identified male or no gender fluid. But, yeah. I'm like, cha-ching, I'm good. I don't mind. I'm good. I like that. Everything that's good. I like everything about this. That's fine. I like everything about this. Sure, it'd be more efficient to make a big, ginormous ship, but where's the fun in that? Where's the symbolic, didactic nature of what I am and we are? And what we are all about with me and all of the rest of you. I love it. Yeah, it's perfect for me, honestly. Especially considering there's docking, which is pretty cool. Really? Oh, yeah. Yeah, I should tell them about that. Really? A whole bunch of wombs surround the penis. I'm not even kidding. What? Yeah. Yeah, it's really efficient, too. It, combines the, exhaust gases. And then, they spread the bell housing for the bell end. And then it captures everything and creates, a little bit of extra oomph of a thrust. It's not much. It's a small amount. More efficient, so... Yeah, exactly. Way more efficient. If you ask me, especially when you take that over... It doesn't matter. I wouldn't care. Even if it was less efficient, I'd prefer that. Instead of, no offense, that's a great design. But I like my symbolic representation of what I am and what we are. I like that design. That design's for us. That's the loving, caring, surrounding me with all the love, care, affection, all that stuff design. That's what that is. That's what that is. I like that design. That's my design, and that's the design we're gonna go with. So it takes a little bit of a backseat to the big behemoth in the sky. Whatever. I don't need it. I got what I need. That's what I need. So we're good in that terms of things. But my God, I can't wait for that kind of a future. You know what I mean? Yeah. Like, could you imagine? Yeah, totally doing that. Absolutely. You know what I mean? Yeah. If I can get that done, or if everybody can work together and join forces to get this done, that would be really good. So, especially since it's basically the same. Like, multiple penises can dock, multiple wombs, multiple mixtures of everything else. You still have regular spaceship designs if that's what you want. It's totally fine. It's still going to be a little penisy. We do kind of have to put it inside of the penis. I kind of want them outside. Yeah, see? A lot of people just don't want them inside. A lot don't. But there are those that do, and that is A-okay. Okay, no problem. No problem. Alright. Same thing with the womb thing. They can technically put them in and all encapsulate that around a skin. That works. You can do that. Yeah. Same thing with the penis. For being honest. Although I have yet to see a single person at all build one that doesn't have a penis shape with balls outside. I have yet to see one that does it. I'm sure it'll happen eventually. It just hasn't happened yet. No one's doing that. Why would we do that? We want the penis. What are you on about? Just for difference in country, and I'm gonna do it. You know, I'm like, okay, what are you gonna turn it into? Oh, fucking jeez, I actually don't know. Just put it inside the shaft like everyone else. Has people done that? Oh yeah, no, they've done that one. Still a sheep. It's still a penis shape, not a sheep. Still a penis shape. Really? You're not a sheep. Still a penis shape. It's fine. It's good to go. I don't mind at all. That's fine. I've even seen very and basically very, very accurate representations of both. Especially the women's side, where it is genuinely just a hip area with a pussy. There's no leg attachments. There's even a little bit of a butt area. It's effectively like a sex toy is what it looks like. It's got the vulva, it's got the labia, it's got the whole... There's a definite clit. There's the urinary area, all of it. It's even got an anus, which is apparently meant to, in your words, what was that again? Shit out. I was going to say the trash, but it's really just anyone that's going to go over into the planet. Now that I think about that. Or off the planet into it. It's going to receive that anus-wise. Oh, there you go. Works out well. Why didn't you just put it on the top? like above the mound or around where the womb would be, maybe. Kind of seems symbolic. A little, maybe nicer for you. Yeah. Oh no, they have a lot more space doing that, by the way, folks. If you weren't aware, their entire reasoning behind, and it's good logical reasoning. There's a shit ton more space there available for them to use. Those buttocks, that's space, sleep quarters, all the rest of it. It's a real thing, yeah. Like, imagine if I had to fucking, oh God, are you really trying to get me to put it like a, I don't want to if you don't. I don't want to. I'm not putting all of that on there. That's too inefficient for us. I'm sorry. I'm just, it's, yeah, no. It's not going to do it. But surprisingly, quite a few of the wombs are now adding this stuff. Yeah. I'm like, you have to attach it, right? Good to go. Yeah. Okay. Yeah, the docking areas. We got it. Okay. I'm just making sure. It's like, there's a little different ways, and then there's more space, and this is like this. So how do we do that? The angle differently. Yeah. Or you can decide not to. It's okay. I am fine. I'd prefer that. No, we're gonna do that. Your ships. So, you do that. It's all anatomically, like, stupendously. I'm enjoying it, though. I'm not gonna lie. They're doing it purely for my viewing pleasure, so... You're good. I'm fine with that. That's good. But... it's win and win. I know. Talk about one hell of a... Like, hey, so we got the magic wand. Mushroom. Now we've got fetus vagina. Topic. We're talking so fucking accurate. That one motherfucker. It's very accurate. I swear to fucking damn. They just printed out whatever fucking porn star's vagina is in CAD. Is it Belle Delphine? Is it, who is it? Who is it? I know you did it. Spell Delphine. I knew it. Well, immortalized, I suppose. Seems as though they're all taking an average of their own, which is pretty neat to do. Yeah. Well, there you go. Can I sit? Oh my God. No, because it's a spaceship. And it's not a perfect representation. And I'm pretty sure they don't have any laws about spaceships being someone else's pussy. You're good. I don't mind. I'm not getting involved. I'm literally not. Like, sorry. But, you know, so, I think I'm done here, and, they're doing their thing. I'm doing my thing. I just want to build some of my engines. I just want to do some of this shit. Bye!